In the leaf litter under the rotting log in the damp seam where the foundation meets the soil, something is moving. It does not buzz. It does not warn. It runs low and fast across the ground, a ribbon of armored segments, and every one of those legs carries it towards something alive. It has hunted this way since before the dinosaurs drew breath. It needs no light. It needs no sound. And when it finds you or finds the cricket beside you, the strike comes from the front, from a pair of legs that were never meant for walking. This is the centipede. Older than the trees, older than flowers. One of the first hunters ever to leave the water and take the land, and it is still here, still hunting in the dark just beneath your feet. We share the house with it and never see it. We turn on the light and it is already gone. To understand what it is, you have to go back hundreds of millions of years to the moment predators first learned to walk on dry ground. It has not stopped since. It does not need us. It does not fear us. It simply waits for the dark, and the dark always comes. Look at the front of a centipede, and you will not find fangs. You will find legs. The very first pair of legs just behind the head has been rebuilt by evolution into something else entirely. A curved pair of hollow claws called forcipules. They hinge inward like a pincer, they pierce and they inject. No other animal on earth kills this way. A snake bites with its mouth. A spider strikes with fangs. The centipede grips its prey with weapons that began as walking legs and became hypodermic needles. Scientists call them forcipules. The rest of us would call them what they are, fangs in the wrong place. Up close, you see them close in a fraction of a second, two black hooks driving into a struggling insect and pumping venom straight into the wound. The mouth, just behind them, does the eating. The forcipules only do the killing. It is a strange division of labor, and it is brutally efficient. The animal does not need to swallow you to harm you. It needs only to touch you with the front of its body. Think of it like a hunter who keeps the knife in his hands instead of his teeth, always drawn, always ready, the first thing the prey ever meets. For the cricket, the spider, the cockroach in the dark, the last thing they feel is not a mouth. It is a grip. Most centipedes you meet cannot hurt you. The giants are different. The largest members of the genus, Scolopendra, carry venom strong enough that people who have been bitten describe the pain in the language of injury. A deep throbbing burn that spreads from the wound and lingers for hours, sometimes for dark days. The bite site swells. The skin reddens. Some people report waves of pain that pulse long after the animal is gone. Fatalities are extraordinarily rare, and healthy adults almost always recover fully, but the experience is one few forget. Imagine pressing a lit match to your skin and holding it there, then feeling that heat travel up the limb in slow pulses. That is closer to the report than any clinical word. The venom is not designed for us. We are far too large to be prey. What we feel is collateral, a chemical meant to drop a beetle in seconds, scaled down by our size into something merely agonizing. Researchers study these bites carefully because the giant species defend themselves readily when handled, and they strike fast. Stand close enough to one in the wild and you understand the instinct to step back. The body lifts at the front, the forcipules open, and in that posture there is a clear message, older than language: come no closer. Most who ignore it learn why the warning exists. The strike happens before you register that anything has moved. A centipede hunts in places with no light at all, under stones, deep in soil, in the black throat of a cave, and it does not need to see its prey to seize it. The whole front of the body is a sensing instrument, and when the antennae brush against something alive, the response is nearly instant. The head whips toward the contact. The forcipules drive in. To the prey, there is no warning shot, no slow approach. There is the dark, and then there is the grip. Slow the footage down as you can watch the body fold into a lunge faster than a human could flinch. In real time, you would simply miss it. The animal processes the touch, decides and attacks in a window measured in the smallest fractions of a second. This is what makes the centipede so successful in the lightless world it owns. Eyes are slow. Eyes need photons, and photons are scarce underground. Touch is immediate. The centipede has built its entire hunt around the fastest sense it has, and in the dark, that choice makes it nearly unbeatable. Picture reaching into a drawer you cannot see and having something seize your fingertip the instant you brush it, no pause, no hesitation, pure reflex. That is the prey's experience every time in a world where the lights never come on. There is a shape humans do not like, and the centipede wears it. Long, low, segmented, fringed on both sides with legs that move in waves, the silhouette alone is enough to lift the hair on the back of the neck. Researchers who study fear and disgust point to this body plan again and again, too many legs moving too fast, in a form that is hard for the eye to track. We can look at a beetle and feel nothing. We see a centipede flow across the floor and something far older than reason flinches. The reaction is fast, automatic, and remarkably consistent across cultures that have never shared a folktale. Part of it may be the motion, that rippling liquid gait that does not move like anything we are built to trust. Part of it may be the sheer count of legs, more than the eye wants to process at once. From above, on a pale floor, the animal reads as a single dark stroke that suddenly fractures into 100 moving parts. The brain does not finish the calculation before the body has already recoiled. This instinct is not foolishness. For most of human history, a fast, venomous thing in the dark was worth fearing, and the ones who flinched first lived to flinch again. The centipede simply triggers a very old alarm, one we never learned and never quite unlearn. A centipede does not check the size of a thing before it attacks. The larger hunting species routinely take prey as big as themselves, and sometimes bigger: frogs, lizards, mice, small snakes, animals with their own teeth and their own will to live. The centipede commits anyway. It grips with the forcipules, injects, and then holds on through everything the prey can do to escape, riding out the struggle while the venom does its work. It is a strategy of total commitment. There is no testing bite, no release and wait. Once the strike lands, the centipede is locked on, and its long body coils to pin the thrashing meal in place. Watch a giant scolopendra take a mouse, and the asymmetry is unsettling. A soft, warm mammal with eyes and breath, going still in the grip of a thing that weighs a fraction as much. The venom is the equalizer. Pound for pound, it is potent enough that mass advantages collapse. The centipede does not need to be bigger, only faster and better armed. It is the difference between a fair fight and an ambush, and the centipede only ever fights the second kind. For prey, several times its weight, the encounter is over, almost before it begins, seized from the front, injected and held until the struggling stops. Few predators its size punch so far above their weight, and fewer still do it so routinely. In the caves of Venezuela lives the largest centipede on Earth, and it has learned to hunt the air. Scolopendra gigantea can exceed the length of a human hand, and in certain caves it climbs to the ceiling, anchors its rear legs to the rock, and hangs into open space waiting for bats. When a bat flies past, the centipede strikes from the wall, seizes the animal in midair, and holds on while both of them dangle from a grip that should not be strong enough to do this. Then it climbs back to safety prey in its claws and begins to feed while the bat is still alive. It is one of the most astonishing predatory feats in the invertebrate world. The centipede has no wings, cannot fly, cannot chase, so it turned the cave ceiling into a trap and made gravity work for it. From below in the dark you would see almost nothing, a long shape against the stone, then a snap of motion, then a bat that simply stops flying. Scientists documented this behavior with no small amount of disbelief, because it asks so much of the animal: the grip strength, the timing, the willingness to hang over a void and trust a few hooked legs to hold the weight of a struggling mammal. It does all of it in total darkness by touch. A hunter that catches the things that fly. Centipede venom is not one chemical, but a deep mixture, dozens upon dozens of distinct compounds blended into a single dose. Some attack the nervous system, some break down tissue, some target the heart and the flow of blood. Together they form a cocktail tuned by hundreds of millions of years of evolution to do one thing very well: stop a struggling animal before it can fight back or flee. The speed matters. A centipede grips prey that may be larger and stronger than itself, and it cannot afford a long battle. So the venom is built for fast collapse, to flood the victim's body with chaos in the first seconds after the strike. Researchers who map these toxins keep finding new ones. A single species can carry a pharmacy of molecules, each one a tiny key shaped to jam a specific lock in the prey's biology. It is less like a poison and more like an orchestra, many instruments striking at once. And because each component does a different job, the prey has no single defense to mount. Block one pathway and 3 others are already failing. Scientists still aren't sure exactly how all of these compounds interact in a live strike, because the mixture is so complex and acts so fast. What they do know is that it works reliably, repeatedly, in a window of seconds. The centipede grips, the cocktail floods in, and the fight very quickly goes out of whatever it caught. Once a centipede locks on, letting go is not part of the plan. The forcipules hook inward, curved like talons, so that the prey's own struggling only seats them deeper. Pull away, and you drive the claws further in. Behind that grip, the long body goes to work. The legs along the centipede's flanks grab the prey from every angle, dozens of small anchors latching at once, while the trunk coils to wrap and pin. It is not one hold, but 100 distributed down the entire length of the animal. Imagine being seized not by a single hand, but by a rope that grips you everywhere it touches, tightening wherever you push against it. That is the centipede's embrace. The harder the prey fights, the more contact points engage, and the venom is already working from within to drain the strength out of the struggle. For a smaller animal, there is simply no leverage to break free, no single point to pry loose, because the grip is spread across the whole body. Even larger prey, several times the centipede's weight, find the hold maddeningly secure. They can thrash, but they cannot dislodge what is clinging to them from end to end. By the time the venom takes hold, escape was never really on the table. The centipede committed the instant it struck, and its entire body is built to make that commitment stick. It does not let go. It waits. When a centipede decides to move, it is suddenly somewhere else. The legs ripple in fast waves down both sides of the body, each pair lifting and falling just out of step with the one before it, and the result is a gait so quick the individual legs blur into a single flowing motion. House centipedes, the long-legged ones that appear on bathroom walls, are among the fastest invertebrates of their size, capable of crossing open ground in a blink. From above on a tiled floor, the animal reads less like a thing walking and more like a dark stroke being drawn across the surface by an invisible hand. The speed is what unsettles people most. A beetle trundles, a centipede flows. There is no warning wind-up, no slow gathering of pace. It is still, and then it is gone, and your eye arrives a moment too late to where it used to be. That velocity serves the hunt and the escape equally. The same legs that close the distance on prey carry the centipede out of danger before a predator can commit. Coordinating that many limbs at that speed without a single tangle is a feat of the nervous system we will come back to, but in the moment, all you register is the blur. Try to catch a house centipede with your hand and you learn the lesson instantly. Your hand is slow, the centipede is not. The centipede belongs to the night. Through the daylight hours it stays hidden under bark, beneath stones, deep in the soil where the air stays damp and the light never reaches. It waits. Then, when the sun is gone and the world cools, it comes out to hunt. This is why most people share their homes and gardens with centipedes for years and never meet one. The animal's entire schedule is built to avoid the hours we are awake and watching. In the dark, it is the centipede that holds every advantage. It hunts by touch and chemistry senses that do not care whether the lights are on, while its prey and its predators are half blind. Picture a hallway at 3 a.m, every surface, still nothing moving. That is the centipede's hour. Somewhere along the baseboard, a long shape is flowing silently toward the warmth and the scent of something alive. There is no sound to wake you, no shadow you would notice. The ambush works precisely because nothing announces it. By the time a cricket senses the centipede, the antennae are already on it. By the time you flick on the light, the animal is already gone, folded back into a crack too narrow to follow. It is not that the centipede hides from us out of fear. It hides because the dark is where it wins, and it has no reason to hunt anywhere else. You almost certainly live with centipedes. The house centipede in particular has thrown in its lot with humanity, moving into basements, bathrooms and damp corners across much of the world, drawn by the moisture and the steady supply of smaller pests. It hunts the things you like even less: cockroaches, silverfish, the larvae of flies, the spiders in the corner. In that sense, it is an ally, a quiet exterminator working the night shift in your walls. But few people feel grateful when one streaks across the tile at midnight. The encounter is always sudden and always brief, a long, fast, many-legged shape appearing where there was nothing, then vanishing under the door before you finish reacting. It asks nothing of you. It does not want your food or your blood. It wants the insects you would rather not think about, and it removes them for free in the dark while you sleep. Stand still in a quiet basement long enough, and you might see one emerge along the wall, antennae sweeping, testing the air for the vibration of prey. Then it is gone again. Most of its visits you never witness at all. The centipede has lived alongside human dwellings for as long as we have built them, a permanent and uninvited guest that earns its keep without ever asking permission. We notice it only on the rare night it crosses our path, and then we remember it for a long time. The giants of the centipede world stretch the imagination of what an arthropod can be. Scolopendra gigantea, the Peruvian or Amazonian giant, can grow longer than a human hand laid flat, a dark, gleaming length of armored segments that flexes and ripples with unsettling fluidity. Hold your hand out and picture that span moving on its own, every segment trailing a pair of legs, the whole thing flowing across a cave floor. These are not delicate creatures. They are heavy-bodied, powerful and fast, with forcipules large enough to break human skin with ease. In the tropics where they live, they sit near the top of the invertebrate food chain, hunting animals that most people would never imagine an insect-sized creature could take. The size changes everything about how they hunt. A centipede this large is no longer limited to bugs. Frogs, lizards, rodents, even small snakes fall within its reach. And reach is the right word, because the body itself is the weapon, long enough to wrap and pin substantial prey, strong enough to hold it through the struggle. There is something deeply uncanny about scale here. We are used to centipedes as small, fleeting things glimpsed at the edge of sight. The giants force a recalibration. This is the same body plan, the same hunting strategy, the same venomous front legs, simply grown to a size where it can look a mouse in the eye and win. When centipede venom enters a human wound, much of the pain comes from how it speaks to the nervous system. Among the dozens of compounds in the mix are molecules that interfere with the channels nerve cells use to fire the tiny gates that open and close to send signals of touch, heat and pain along the body's wiring. The venom pries some of these gates open and jams others shut, and the result is a storm of signals the brain reads as deep burning, throbbing pain. The nerves are not damaged so much as hijacked, made to scream when nothing is truly destroying the tissue beneath. This is why the pain can feel so out of proportion to the small wound that causes it, and why it can pulse and travel in waves up the affected limb. Scientists study these specific molecules closely, because anything that can switch a pain channel on or off so precisely is a key to understanding pain itself. The same compound that makes a centipede bite agonizing might, studied carefully, point toward how to switch pain off. For the prey the centipede actually hunts, of course. This nervous system assault is far more than painful. It is disabling a flood of false signals and failing controls that helps bring the animal down. In us too large to be killed, it lands as pure sensation, the centipede's chemistry meant to drop a beetle, firing every alarm we have at once. No animal has militarized its limbs quite like the centipede. Across the living world, legs do many jobs. They walk, dig, swim, grasp, signal. The centipede took a pair of them and turned them into a venom-injecting weapon system found nowhere else on Earth. The forcipules are evolution's most complete conversion of legs into armament, hollowed out to carry venom, hinged to strike inward, tipped with sharp points and fed by glands that brew the toxin. They are not mouthparts that happen to look leg-like, and they are not modified fangs. Developmentally, they began as the first walking legs of the body, and over deep time they were rebuilt segment by segment into the killing apparatus that defines the entire group. Biologists place them in a category of their own. For exactly this reason, there is no clean parallel anywhere else in nature. Think of it as a creature that, given hands, chose to forge them into knives and never looked back. Everything about the centipede's success flows from this single innovation. The speed of the strike, the commitment to prey larger than itself, the dominance of the lightless underground. All of it rests on having a venomous weapon mounted at the very front of the body, ready before the prey knows it is prey. The legs that might have carried the animal forward instead became the reason anything in front of it should be afraid. It is the signature of the lineage written into the body itself. The centipede hunts the things that hunt. Spiders with their fangs and silk are routine prey. Scorpions, armored and stinging, are taken to the centipede, striking past the tail and the pincers to grip the body and inject before the sting can land. The larger species go further, still killing small snakes, seizing them behind the head and holding on through the coiling and the thrashing until the venom does its work. These are not soft targets. They are armed, dangerous animals with their own weapons and their own venom, and the centipede attacks them anyway with a confidence that comes from being faster and better equipped at close range. Watch a centipede take a scorpion, and the encounter has a brutal logic to it. Two venomous predators meeting in the dark, and the one that strikes first and holds on wins. The centipede almost always strikes first. Its whole front end is built for exactly this, a sensing array that locates the threat and a venom weapon that disables it before the prey's own arsenal can be brought to bear. There is no respect for rank in this world. Being venomous yourself buys you nothing if the centipede reaches you first. It climbs the food chain by refusing to acknowledge that the food chain applies to it taking on opponents, its size that most predators would avoid, and winning by speed, grip, and the willingness to commit completely the instant the antennae find a target. The centipede's body is not just a way to get around, it is a restraint. When the forcipules strike, the long trunk follows, coiling around the prey and pinning it from multiple points at once. The legs along both flanks dig in and hold, and the animal becomes a living loop of muscle and grip wrapped tight around its catch. For prey that fights a mouse, a lizard, a large beetle, this coil is what buys the venom time. The struggle has nowhere to go. Every direction the prey pushes meets another length of the centipede's body pushing back. Picture a thin armored arm wrapping a coil around something 3 times its weight and simply refusing to let the loop open. That is the tactic. The grip up front kills, the coil behind it controls. Together they turn a small predator into one that can safely handle prey large enough and strong enough to do real damage in a fair fight, which is precisely why the centipede never gives it a fair fight. The coil also protects the centipede itself, immobilizing the prey's teeth, claws, or sting before they can find a target. From the outside, it looks almost like an embrace, the long body folded around the catch, growing still as the venom takes hold and the struggling fades. It is one of the oldest holds in the animal world, and on the forest floor it almost always ends the same way. To eat a centipede, you have to get past the front of it, and that is harder than it sounds. A full-grown centipede is not easy prey. It is fast, so it is hard to catch. It is armed with venom, so catching it can cost you. And it fights back from the front with those forcipules striking at the very mouth that tries to take it. Many predators that would happily eat a beetle the same size learn to leave centipedes alone, and the ones that do hunt them tend to be specialists equipped to handle the risk. Some birds, some larger reptiles and amphibians, and certain mammals manage it, but even they must subdue the centipede quickly before it can land a defensive bite. A toad that swallows a large centipede the wrong way can pay for the mistake. The animal does not stop being dangerous just because it has been caught. It can strike from inside a predator's grip, even from inside its mouth. That risk reshapes the menu. It pushes the centipede higher in its world than its size alone would suggest, surrounded by animals that could, in principle, eat it and mostly choose not to. Predation runs on cost and reward, and the adult centipede tilts that math. The reward is one meal. The cost is a venomous bite delivered by a fast, armored animal that does not surrender. For most hunters, the centipede is simply not worth it. Long before science described its venom, humanity had already decided how it felt about the centipede. Across the world, in cultures that never met or traded a single story, the animal appears again and again as something to be feared, a creature of poison, darkness, and ill omen. In some traditions, it is a symbol of menace. In others, a thing of power, precisely because it is dangerous. Folklore tends to gather around animals that quicken the pulse, and the centipede quickens it reliably. The reasons echo what we have already seen: the unsettling body, the speed, the venom, the way it appears from nowhere in the dark. A creature like that does not stay confined to biology. It moves into myth. People who had no microscopes and no toxicology still knew from hard experience that this long, fast thing could hurt them, and they wrote that knowledge into stories and warnings passed down through generations. There is something telling in how consistent the fear is. Separate the world by oceans and centuries, and the centipede still tends to wear the same costume in the human imagination: dangerous, secretive, not to be trusted. That consistency is the instinct we met earlier, dressed in language and handed down. The folklore is the fear made into culture, a record of every ancestor who flinched at the rippling shape on the wall and decided their children ought to flinch too. We inherited both the warning and the unease. The name is a lie in the gentlest possible way. Centipede means 100 feet, and the creature almost never has exactly 100. Some species walk on as few as 30 legs, others carry well over 300. The 100 is a poetic guess from an age before anyone sat down to count, and the real numbers scatter widely on both sides of it. Stranger still, the count is never even. A centipede always has an odd number of leg-bearing segments, which means an odd number of leg pairs, and that single rule quietly forbids exactly 100 legs from ever appearing. To have 100 feet, you would need 50 pairs an even count, and the centipede's body simply does not build itself that way. So the animal that gave us the word 100-legged is, by its own deepest biology, incapable of having 100 legs. There is something fitting in that. The centipede has always been a creature of misnaming and misunderstanding, feared for things it does not do, and named for a number it cannot reach. Picture trying to count the legs as the animal flows past. The task is hopeless. The legs a moving blur. And 100 feels as good a guess as any in the moment. But slow it down, count carefully, segment by segment, and the truth emerges. Never 100, always odd, and governed by a rule we are only beginning to understand. The name is wrong, and the reason it is wrong is far more interesting than the name. Here is one of the strangest facts in all of zoology. No matter the species, no matter the size, every adult centipede has an odd number of pairs of legs. 21 pairs, 23, 45. Never 22, never 44. The rule holds across thousands of species and hundreds of millions of years, an iron constraint written into the deepest layer of how a centipede is built. And nobody is entirely certain why. The pattern is set as the animal develops in the way its body divides into segments, and something in that process refuses to produce an even count of leg-bearing rings. It is one of the most reliable rules in the animal kingdom, and one of the least explained. Scientists still debate the developmental machinery behind it, the genetic and embryonic switches that force the body to land on odd every single time. Think of it like a coin that can be flipped 1,000 ways and somehow always shows an odd face. The consistency itself is the mystery. A creature that varies so much in everything else: length, leg count, color, habitat, size from a few millimeters to a foot, holds this one number constant without exception. The diversity is enormous. The rule is absolute. That tension is what makes it uncanny. The centipede is wildly variable and rigidly constrained, at the same time free to become almost anything except a creature with an even number of leg pairs. The why of it remains genuinely open. The centipede is built like a train. Its body is a long chain of nearly identical segments, and along most of that chain the pattern repeats with mechanical regularity: one segment, one pair of legs. Segment, legs. Segment, legs. Down the entire length of the animal. This modular design is the secret to how the centipede can come in so many sizes while keeping the same basic blueprint. Need a longer animal, add more segments, each one bringing its own pair of legs. The body scales by repetition like adding cars to a train, and the underlying unit never has to change. It is an ancient and elegant solution, and it shows up across many of the oldest animal lineages, this idea of building a complex creature out of a single part, repeated again and again. In the centipede, the repetition is unusually clean and unusually visible. Look closely, and the body reads almost like a diagram of itself. Each module a copy of the last, the legs marching down both sides in matched pairs. From above, the effect is hypnotic, rank after rank of identical limbs, all coordinated, all moving in sequence. The design has consequences we will explore. It shapes how the animal moves, how it survives, losing parts of itself, how it grows. But at its root, it is beautifully simple. A centipede is the same small idea repeated again and again until it becomes a hunter long enough to wrap around a mouse. We met the forcipules as weapons. Now, meet them as a transformation. The most uncanny thing about a centipede's venom claws is not what they do, but what they were. They are legs, the first pair, the body grows, the segment right behind the head, reshaped by deep time into something that no longer walks at all. Trace the development of a centipede, and you can see it a pair of limbs that, in a distant ancestor, carried the animal forward, gradually pulled toward the mouth, curved, hollowed, and armed, until they became the defining feature of the entire group. Evolution does this. It takes a part built for one purpose and slowly repurposes it for another, but rarely so completely, and rarely with such consequence. A walking leg became a hypodermic claw fed by venom glands, hinged to strike inward at anything the antennae find. There is something almost unsettling in seeing the leg nest still in them, the segmented structure that betrays their origin even as they do a job no leg was ever meant to do. Picture a hand, slowly over millions of years, folding itself into a syringe. That is the forcipules story. It is why the centipede's mouth region looks so strange up close. There are limbs where you expect jaws, weapons where you expect feet. The animal kills with its hands in the most literal evolutionary sense, and the legs that became those hands are the reason the whole lineage exists in the form it does. A centipede has no lungs and no chest that rises and falls. It breathes through holes. Along the sides of its body run tiny openings called spiracles, and behind each one branches a network of fine tubes that carry air directly into the tissues. No blood-borne oxygen, no central pump for breath, just air piped straight to the cells that need it. The animal does not inhale in any sense we would recognize. It simply lets the outside air seep in through these ports and diffuse along its inner plumbing. It is a radically different way to be alive. Where we route every breath through a single pair of lungs, the centipede distributes the job across its whole length. A series of small intakes feeding a body too long and low for any other arrangement to work. The design is ancient and shared by many arthropods, but in the centipede, it carries a hidden cost. We will come to those. Open ports are also where precious water escapes. For now, sit with how strange it is. There is no breathing to watch, no sign from the outside that the animal is taking in air at all. It runs, it strikes, it holds prey through a violent struggle, and all the while oxygen is quietly slipping in through rows of microscopic holes in its sides. A creature that breathes everywhere at once and nowhere you can see. The centipede wears its skeleton on the outside. Its body is sheathed in a hard cuticle, an armored shell that protects it, holds its shape, and anchors its muscles. But this armor has one fatal limitation. It cannot grow. The shell is fixed, and the living animal inside it does not stop getting bigger. So the centipede faces a problem every armored creature must solve to grow. It must shed. Periodically it splits the old cuticle and crawls out of it, emerging soft, pale and larger, then waits as a fresh shell hardens around the new size. This is molting, and it is one of the most dangerous moments in a centipede's life. For a window of hours, the fierce hunter is defenseless, its armor gone, its forcipules too soft to strike, its body vulnerable to anything that finds it. Picture the predator we have built up across all these facts, suddenly stripped of every weapon, naked and slow in the dark, waiting for its skin to turn hard again. The contrast is striking. The same animal that hangs from cave ceilings to snatch bats must again and again throughout its life become utterly helpless to grow at all. It is the price of the armor. The exoskeleton that makes the centipede formidable also traps it, forcing it to abandon its protection, over and over gambling, each time that nothing will find it in the soft hours before the new shell sets. For an animal this lethal, the centipede sees almost nothing. Many species have only simple eyes, clusters of basic light detectors that distinguish bright from dark and little else. Some have no eyes at all. The deep soil and cave-dwelling species, sealed away from light entirely, have abandoned vision completely, their heads smooth where eyes would be. And it does not matter. The centipede was never going to win by sight. In the lightless world it hunts, eyes are nearly useless. There are no photons to catch underground, no images to form in the black. So the animal invested elsewhere, building a sensory life around touch and chemistry that needs no light at all. The eyes where they exist are an afterthought, good for sensing when a stone is lifted and daylight floods in, signaling the animal to flee deeper. Picture a hunter that catches mice and bats and snakes while being, for all practical purposes, blind. It unsettles our assumptions about what a predator needs. We imagine sharp eyes, a fixed gaze, the lock of vision onto a target. The centipede has none of that and dominates anyway, reading its prey through senses we barely use. The blindness is not a weakness it overcomes. It is a choice its lineage made long ago to stop paying for vision it could not use and to pour everything into the senses that work in the dark, where the centipede lives and where light never comes. If the centipede barely sees, then how does it know its world? Through its antennae. The pair of long feelers at the front of the head is the animal's primary window onto everything around it, its eyes, nose, and fingertips fused into two waving probes. The antennae are dense with sensory receptors that read, touch, detect chemicals in the air and on surfaces and sense humidity, vibration, and the faint signatures of prey. When a centipede explores, the antennae are in constant motion, sweeping the ground ahead, testing every surface, building a picture of the surroundings that owes nothing to light. This is the true sensory world of the centipede, not seen, but felt and tasted, assembled from contact and chemistry into something we can barely imagine. Where we walk into a room and take it in at a glance, the centipede reads the same space, stroke by stroke, antenna tip by antenna tip, a world of textures and scents and tremors. Up close, you can watch the antennae work, flicking, probing, never still, gathering the data the eyes cannot. When they brush something alive, the whole animal responds in an instant. The antennae are also what make the strike possible in total darkness. They find the prey and the forcipules do the rest. To understand the centipede, you have to set aside the idea of seeing entirely and imagine a creature that knows the dark intimately, completely through two restless feelers that never stop reading the world. The centipede has a sensory trick at both ends. At the rear of the body, the final pair of legs is different from all the others, longer, thinner, often held up and back rather than used for walking. These trailing legs work almost like a second set of antennae, sweeping the space behind the animal, reading the world it has already passed through. It means the centipede senses in two directions at once, probing ahead with the true antennae, and behind with these modified rear legs, so that very little can approach unnoticed from any angle. This dual awareness serves both hunting and survival. A predator sneaking up from behind meets a creature that is in effect already watching its own back, and the rear legs do more than sense. In some species, they serve as a defense raised and waved, to confuse an attacker about which end is the dangerous one, a bluff we will come to. For now, marvel at the symmetry of the design, a long animal that has turned both of its ends into sensory instruments, refusing to have a blind side. Picture the centipede flowing through a tunnel antennae, reading the dark ahead, rear legs trailing and testing the dark behind the whole length of the body, wrapped in awareness. It is one more way the centipede compensates for its near blindness, and one more reason it is so hard to ambush. Front and back, the animal feels everything coming. Lose a leg and the centipede barely breaks stride. With so many limbs running in coordinated waves, the absence of one or several hardly disrupts the pattern. The remaining legs adjust, the rhythm closes around the gap, and the animal keeps flowing forward as if nothing happened. This redundancy is one of the quiet advantages of the modular body. A creature that depended on 4 legs would be crippled by losing one. A creature with dozens simply carries on the loss, absorbed by the sheer number of working parts. It matters most in a fight. A predator that grabs a centipede may come away with a leg or two while the animal escapes intact and undeterred, the missing limbs a small price for survival. And the loss need not even be permanent through future molts. Many centipedes can regrow what they shed, a regeneration we will return to. Picture a machine built with so many redundant moving parts that you could remove a handful and never see it slow down. That is the centipede underfoot. The design that makes it strange, all those identical segments. All those repeated legs also makes it remarkably hard to disable. There is no single point of failure to exploit, no critical limb whose loss ends the chase. You can take pieces of the centipede and still not stop it. It keeps moving, recalculating its gait on the fly, flowing on toward the dark on whatever legs remain. A centipede can go where almost nothing else can follow. Its body is flattened from top to bottom, pressed low and thin, and that shape is a key. It lets the animal slide into gaps that look far too narrow to admit it. A crack in the soil, the seam under a stone, the slot beneath a door, a fracture in bark if there is the slimmest opening. The centipede can flatten itself further and pour through. This is how it vanishes, the instant a light comes on, why it can be there, and then simply gone, swallowed by a space you would swear was solid. The flattened build serves the hunt as much as the escape. The centipede's prey hides in exactly these tight, dark places in the crevices and tunnels and gaps of the underground world, and the animal is shaped to follow them in. It is a body designed for a life lived in the thin spaces between things, in the cracks of the world, rather than its open surfaces. Picture water finding the gap under a door and slipping through. The centipede moves into a crevice the same way, the whole long body compressing and feeding through an opening that should never have let it pass. We live on the surfaces. The centipede lives in the seams, in the narrow dark between one solid thing and the next, built flat for a world we never think to look inside. For all its weapons, the centipede has a fragile secret. It is always one dry day from death. Those spiracles that let it breathe also let water escape, and unlike many insects, the centipede's cuticle does the job of sealing in moisture poorly. The result is an animal that loses water alarmingly fast, that cannot survive long in dry open air, that must spend its life chained to damp places under logs, beneath stones, deep in moist soil, in the humid dark of caves. This is the great constraint on the centipede's existence. The fearsome hunter we have built up across 30 facts is at its core a creature terrified of drying out, exiled from sunlight and open ground, not by choice but by chemistry. Leave a centipede on hot, dry pavement, and it will not last. The water flees its body through 100 tiny ports faster than it can replace it. Everything about where the centipede lives, when it hunts, how it hides, traces back to this vulnerability. It comes out at night because the air is cooler and wetter then. It haunts basements and bathrooms because those are the damp corners of our dry homes. The same body that makes it a relentless predator also makes it a prisoner of moisture, unable to follow the sun, bound forever to the wet and hidden places. The hunter that fears nothing in the dark fears above all the simple loss of water. A centipede's legs do not move by muscle alone. Like many of its relatives, the animal runs partly on fluid pressure, a hydraulic system that uses the liquid inside its body to help extend its limbs. Muscles pull the legs in. Pressure helps push them back out. The body becomes a kind of pressurized vessel, and the legs are driven by a partnership of muscle and hydraulics, working together down the entire length of the animal. It is a strange way to walk, and it has consequences. It means the centipede's movement is tied to the fluid balance of its body. Another reason that drying out is so dangerous: lose too much water, and the hydraulics that drive the legs begin to fail. But when the system is full and working, it produces that smooth, flowing, rippling gait, dozens of legs extending and folding in coordinated waves, powered by a pressure that runs through the whole creature at once. Picture a long row of small pistons, each driven by the same internal pressure, firing in sequence to carry the body forward. There is something almost mechanical about it, an engineering solution to the problem of moving so many limbs without a muscle dedicated to every motion. The centipede borrows the push from its own fluids, sharing one pressurized interior among all those legs. It is one more way the animal's body is unlike ours at the deepest level, driven not just by muscle but by the quiet hydraulics of a creature built around pressure and flow. The centipede can rebuild itself. A leg lost to a predator or an accident is not gone for good. Across future molts, many centipedes regrow the missing limb, restoring it piece by piece until the body is whole again. Each shedding of the cuticle is an opportunity to repair, and the animal takes it slowly, replacing what it lost. The regrown leg may start smaller and catch up over successive molts, but the capacity is there, a power of renewal woven into the same process that lets the animal grow. This regeneration deepens the centipede's resilience. We have seen that it can keep moving after losing legs. Now we see that the loss need not even be permanent. A predator that strips a limb in a failed attack leaves the centipede not only alive but in time restored. Picture an animal that treats the loss of a leg as a temporary inconvenience, a thing to be undone at the next molt. It is a kind of slow-motion healing that our own bodies cannot match. We do not regrow lost fingers, but the centipede regrows lost legs as a matter of course. Scientists study this regenerative ability with real interest, because the capacity to rebuild complex body parts is rare and precious in the animal world. For the centipede, it is simply part of being alive. Shed the old shell, grow a little larger, and along the way quietly replace whatever the world has taken. The centipede plays a trick of identity. We have seen that its rear legs are long and antenna-like, sweeping the space behind the body. Those same legs serve a second purpose: deception. When threatened, some centipedes raise and wave the rear legs in a way that mimics the antennae at the front, making it genuinely hard for an attacker to tell which end is the head. A predator aiming for the vulnerable head may strike at the tail, instead leaving the true weapon, the venomous forcipules, free to counterattack from the other direction. It is a bluff written into the body, a built-in decoy. The animal turns its own anatomy into a riddle, two ends that look alike, one harmless and one armed, and an attacker forced to guess. Guess wrong, and you have committed to the wrong end while the forcipules come around to find you. Picture a creature that has in effect painted a fake face on the back of its head, so that whatever lunges at it cannot be sure where the danger lies. The strategy fits everything we have learned about the centipede, an animal that refuses to have a weak side, that has turned both of its ends into sensory tools and now into defensive ones. The confusion buys time, misdirects the strike, and protects the head that holds the brain and the weapons. It is deception by design, the body itself telling a lie to survive. To be this long and this thin, the centipede had to rebuild its insides. Its organs are stretched and repeated along the length of the body, rather than packed into a central core the way ours are. The heart runs as a long vessel down the back. The nervous system threads the entire body as a chain of repeated control centers, one cluster serving each region, rather than a single brain commanding everything from the front. The breathing tubes branch in along every segment. Nearly every system is distributed, spread out, modular, matched to a body that is mostly length. This is the inner face of the segmented design we met earlier. From the outside, the centipede is a chain of identical rings. On the inside, it is a chain of repeated organs and nerve centers, the same unit copied down the line. It is what makes the modular body actually work. You cannot stretch an animal into a long ribbon and keep all the vital machinery crammed at one end. The centipede solved this by sharing the load, giving each stretch of the body its own portion of the systems that keep it alive. It is part of why losing a section is not immediately fatal, why the animal can keep functioning after damage that would kill a more centralized creature. The centipede is not one center with a long body attached. It is a long body that distributes life along its entire length, organized for the shape it has chosen to be. The centipede listens with its body. It has no ears in any familiar sense, but it is exquisitely sensitive to vibration, the faint tremors that travel through soil, wood, and stone when something moves nearby. Through receptors on its legs and antennae, the animal reads these ground-born signals, feeling the footsteps of prey and the approach of danger as quivers in the surface it stands on. In the dark world where the centipede lives, this is invaluable. A beetle scuttling across the leaf litter sends out a tiny seismic signature, and the centipede, blind or nearly so, picks it up and turns toward it. The ground itself becomes a source of information, every surface, a membrane carrying news of movement. Picture a hunter that feels its prey coming through the floor before any other sense could find it, reading the trembling of the earth like a language. This vibration sense works seamlessly with the chemistry. The antennae detect the two streams combining into a picture of the surroundings that needs no light at all. It also serves as an early warning. The heavy tread of an approaching predator registers as a vibration the centipede can flee from before the threat arrives. We rarely think about the information humming through solid surfaces, the constant faint signals of everything that moves. The centipede thinks about little else. It lives pressed against the ground, tuned to its tremors, hunting and hiding by the language of vibration. The centipede's shell is a compromise with thirst. Its cuticle carries a waxy layer meant to slow the loss of water, a thin barrier standing between the animal and the dryness that would kill it. But the barrier is imperfect, weaker than the sealing armor of many insects, and so it only delays the inevitable rather than preventing it. The waxy coat buys the centipede time, extending how long it can survive away from moisture, but it cannot make the animal truly waterproof. This is the fragile equipment behind the constraint we met earlier. The centipede is not careless about water loss. It carries the best seal its lineage has managed to evolve. It simply is not enough to free the animal from its dependence on damp. The wax slows the leak. It does not stop it, and so the centipede remains bound to humid places, its survival measured in how long the waxy layer can hold the water in before the dry air wins. Picture a vessel sealed with a coating that slows the seep, but never quite closes it, always losing a little, always needing to return to the wet to refill. That is the centipede's daily reality. The same animal that hangs from cave ceilings and takes down snakes lives at the mercy of this thin, imperfect coat, every hour in dry air, a slow drain it cannot fully prevent. The armor that turns a predator's bite also quietly fails at the simpler job of keeping the water in. Centipedes wear a wide range of colors, and the boldest of them are saying something. Many species are drab browns and tans and dull reds that vanish into soil and leaf litter camouflage for an animal that wants to stay unseen. But others blaze with warning, vivid yellows, deep reds, striking bands of dark and bright. These are not decoration. Bold, contrasting color in the animal world is often a signal, a message to anything thinking of attacking, that this creature is dangerous, venomous, not worth the risk. The centipede that advertises is making a deal with its predators. Remember this color and remember the pain. It is the same logic that paints wasps and venomous snakes in vivid hues, honesty as defense, the body announcing its danger so the fight never has to happen. Picture a centipede banded in warning colors flowing across a forest floor, conspicuous rather than hidden, daring anything to test it. For the animals that have learned the lesson, the color alone is enough to turn them away. The variation across species tells a story of different strategies, hide or warn. Some centipedes bet on never being seen. Others bet on being seen and remembered. Both are answers to the same problem of staying alive in a world full of things that might eat you. And the warning colors carry an extra weight because the centipede backs the threat completely. The venom is real, the bite is genuine, and the bright bands are not a bluff but a promise. The centipede settled on its design almost unimaginably long ago and has barely changed it since. The basic blueprint, the long, segmented body, the pair of legs per segment, the venomous forcipules at the front, was already in place hundreds of millions of years ago in some of the earliest animals to walk on land. While the world transformed around it again and again, the centipede kept the same fundamental shape, refining the details but never abandoning the core idea. There is profound success hidden in that stillness. A body plan does not survive that long by accident. It survives because it works, because it solves the problems of being alive so well that there is little reason to change it. The centipede found an answer early: how to be a fast, venomous, ground-hunting predator. And the answer has held up through extinctions, climate upheavals, and the rise and fall of countless other forms of life. Picture a design so sound that it has run essentially unaltered since before the first dinosaur, outlasting nearly everything that ever competed with it. That is the centipede's quiet boast. It is not a relic clinging to an outdated form. It is a proven solution, still running at full capacity, the same ancient idea, hunting in the same ancient way, in the soil beneath us right now. The world has reinvented itself 1,000 times. The centipede looked at its own design, found it good and kept it. Stop and consider the problem the centipede solves every second it moves. dozens of legs, sometimes hundreds, all firing in sequence, each one lifting and falling at precisely the right instant and never somehow tripping over one another. For us, walking on two legs already demands constant unconscious calculation. The centipede manages 40-8300, flowing them in seamless, coordinated waves across uneven ground, around obstacles, up walls, through cracks. It is a feat of biological control that engineers building walking machines study with envy. The secret lies in the distributed nervous system we met earlier. The centipede does not run all those legs from a single overworked brain at the front. Instead, control is shared down the body. Local nerve clusters managing their own stretch of legs while staying in rhythm with their neighbors. Each region handles its part, and the parts pass the wave along. Picture a line of people doing a stadium wave, each one watching the neighbor and rising at the right moment, the motion flowing down the line without any single conductor commanding every body. The centipede's legs work something like that, a coordinated cascade rather than a centrally micromanaged march. The result is the smooth, hypnotic, blurring gait, and the fact that the animal can lose legs and keep flowing without missing a beat. It is one of the most elegant solutions to motion in the animal world. A creature that turned the nightmare of controlling 100 limbs into the most natural thing it does. The trick to running on 100 legs is timing, and the centipede's timing is exquisite. Each leg moves slightly out of phase with the one in front of it, so that at any instant neighboring legs are at different points in their stride, one lifting as the next sets down. This staggering sends a visible wave rippling down the body, and crucially, it keeps adjacent legs from ever reaching for the same patch of ground at the same moment. They never collide because the rhythm forbids it. Faster movement changes the pattern. The waves tighten and shift as the animal accelerates, the legs adjusting their phase to keep the whole system clean at any speed. It is a continuous, self-organizing solution to a problem that should, by rights, end in a tangle of limbs. And yet it almost never does. Scientists who study legged locomotion find these gait patterns genuinely beautiful, mathematical, regular, robust enough to survive the loss of legs or the roughness of the terrain. Picture 1,000 oars on a long boat, each dipping a fraction of a beat after the one ahead. The strokes flowing down the hull in a wave that drives the whole thing forward without a single oar fouling another. The centipede rows across the ground that way, its legs, the oars, the wave, its engine. The pattern is what turns dozens of independent limbs into one smooth motion, and it runs automatically, endlessly, every time the animal decides to move. Not every centipede hunts the same way, and the choice reveals a kind of strategy. Some are ambushers waiting motionless in the dark for prey to wander within reach, conserving energy and striking only when the odds are best. Others are active hunters roaming through the soil and leaf litter, antennae sweeping, retting prey down across their territory. The fast, long-legged house centipede leans toward active pursuit, chasing and seizing with speed. Heavier-bodied species more often wait and ambush, letting the prey come to them. The strategy fits the body and the habitat. A creature built for speed hunts by moving. A creature built for power and patience hunts by waiting. And many centipedes can do both, shifting between stalking and ambush depending on what the night offers. This flexibility is part of why the group has been so successful across so many environments. There is no single rigid script, but a repertoire the animal can draw from. Picture two hunters in the same dark forest, one pacing the trails, reading every tremor and scent for a target, to chase the other folded into a crevice, perfectly still, letting the world bring dinner to its doorstep. Both are centipedes, both win. The strategy is not an accident of habit, but a response to circumstance, the animal matching its method to its body, its prey, and its place. It is a small window onto how much more is happening behind those simple eyes than the centipede's reputation as a mere reflexive striker would suggest. In total darkness, the centipede builds a map. Its antennae sweeping constantly read the chemical and physical world tip by tip, the scent of prey, the texture of surfaces, the moisture in the air, the faint stir of something moving. From this stream of contact and chemistry, the animal assembles a working picture of its surroundings and the living things within it, all without a single ray of light. When a prey animal is near the antennae, locate it with startling precision, fixing its position closely enough for the forcipules to strike true. This is mapping by feel and smell, a spatial awareness constructed from senses we use only faintly. Where we would be utterly lost in the absolute dark of deep soil or a cave, the centipede is fully oriented, its antennae painting the space around it in dimensions of scent and touch and vibration. Picture finding your way across a pitch-black room and locating a fly by smell alone precisely enough to catch it on the first grab. That is something close to the centipede's nightly reality. The antennae do not just detect that prey exists, they fix where it is tracking it as it moves, guiding the strike to the exact spot. It is one of the quiet marvels of the animal that a creature so simple in our imagination carries out in the dark a feat of real-time spatial mapping that our own technology struggles to match. The lights are never on, and the centipede never needs them. The centipede hunts with the whole environment as its informant. Beyond scent, it reads the movement of air and the tremor of the ground, two more channels feeding its picture of where prey might be. A faint current stirred by a passing insect, a vibration carried through the soil by scuttling legs. The centipede gathers these signals and combines them, cross-referencing air and ground and chemistry into a single conclusion: something alive is over there. This sensory fusion is what makes the animal so hard to escape. Prey that evades one sense betrays itself to another. Stay still and avoid stirring the air, and your footsteps still tremble the ground. Tread lightly, and your scent still drifts on the current. The centipede is reading multiple streams at once, and the combination closes the gaps that any single sense would leave. Scientists studying these animals find a sensory system far richer than the simple eyes would suggest. An integration of touch, chemistry, air, and vibration into seamless awareness. Picture a hunter that feels the breath of the room, the trembling of the floor, and the scent on the wind all at once, weaving them into a single certainty about where to strike. That is the centipede in its element. It does not rely on one trick. It listens to everything the dark has to tell it, the air, the ground, the chemistry, and lets the signals converge on the meal. By the time the prey senses the danger, the centipede has already triangulated it from 3 directions at once. Watch a centipede make a kill and you see a sequence honed to ruthless efficiency. First detection, the antennae or vibration sense fix the prey's position in the dark. Then the lunge, the front of the body whipping toward the target faster than the eye can follow. Then the pin, the forcipules, and the leading legs seizing and holding the prey in place. And finally, the inject. The venom claws driving in and pumping the toxic cocktail straight into the wound. Detect lunge pin, inject 4 beats executed in a fraction of a second each, flowing into the next without hesitation. There is no wasted motion in it. The centipede does not circle, does not test, does not deliberate once the sequence begins. The detection triggers the lunge sets up the pin secures the target for the injection, and the venom finishes what the grip started. It is a chain of actions compressed so tightly in time that to the prey it registers as a single event: contact and then capture. Picture a closing trap where every part fires in order, the spring released, the jaws shut, the lock engaged, all in one continuous motion too fast to interrupt. The centipede's strike works the same way. Up close in slowed footage, you can pick the 4 beats apart and admire the precision of each. In real time on the dark forest floor, there is only the strike, sudden, complete, and over before the prey understood it had begun. Venom is expensive, and the centipede appears to spend it wisely. Producing the complex toxic cocktail costs the animal real energy and resources, and a centipede that empties its venom glands cannot immediately refill them. So there is strong evidence across venomous animals and signs in centipedes of venom economy. Metering the dose to the target, using less on small prey and more on large or dangerous opponents. The animal does not waste a full lethal load on a meal that a small dose would handle. This metering is a form of decision-making, however simple its mechanism. The centipede, in effect, assesses what it is dealing with and calibrates its most precious weapon accordingly, conserving venom for the encounters that truly demand it. Scientists still study exactly how finely centipedes control their dosing and how much is deliberate versus reflexive, but the underlying logic of venom economy is well established across the venomous world, and the centipede's costly, slow to replenish venom gives it every reason to ration. Picture a hunter with a limited supply of an irreplaceable poison, careful never to spend more than the job requires, saving the heavy doses for the prey that could fight back or the predator that must be repelled. That is the pressure the centipede lives under. Its venom is not infinite, and the animal that uses it well, striking with just enough, hunts more often and survives more encounters than one that squanders its arsenal on every passing beetle. The economy is survival written into how the centipede spends its chemistry. For all its fearsome reputation, the centipede is capable of devotion. In many species, the mother does not lay her eggs and abandon them. She stays. She coils her body around the clutch, shielding the eggs with her own length, guarding them against predators and the dangers of the dark. For weeks she remains, and the transformation is striking the same animal that hangs from cave ceilings and takes down snakes, now wrapped protectively around a cluster of eggs, fierce in their defense rather than in the hunt. This maternal care is rare and remarkable among creatures of this kind, and it reshapes how we should see the centipede. We have built it up as a pure predator, a reflexive killing machine of venom and speed. But here it is, tending its young with patience and persistence, investing weeks of vulnerability in the next generation's survival. The mother often does not even leave to feed, living off her reserves rather than abandon the clutch. Picture the contrast: a venomous hunter that catches bats from the air, curled in the dark around its eggs, unmoving, on guard for as long as it takes. It complicates the monster. The centipede is not only a weapon, it is in these weeks a guardian, and the care it shows its eggs is among the more unexpected and moving things in its entire biology. We will see in the next facts just how far that devotion extends into cleaning, defending, and nurturing the clutch through every threat the dark can offer. The image stays with you: a centipede mother wrapped entirely around her eggs, her long body forming a protective coil, holding that pose for weeks on end. She does not hunt during this time. She does not wander. She commits herself almost completely to the single task of keeping the clutch alive, living off the reserves stored in her body rather than leaving the eggs unguarded even for a meal. It is one of the longest sustained acts of devotion in the invertebrate world. Throughout this vigil, the eggs are intensely vulnerable to predators that would eat them, to the fungi and bacteria of the damp world that would rot them to any disturbance in the dark. The mother's body is their shield against all of it. She curls tighter at a threat, repositions to keep the clutch covered, and stays through every danger the long weeks bring. Picture a guardian who refuses to leave her post for weeks, going hungry, rather than abandon what she protects, her own length, the only wall between her young and the world. There is something almost contradictory in it. The venomous, solitary hunter, famously a creature of cold efficiency, here transformed into a patient, sacrificing mother. The two facts sit side by side in the same animal. She will return to hunting once the young can fend for themselves, become again the predator we fear. But for these weeks she is only this, a body wrapped around the future, holding still in the dark, waiting for her eggs to become centipedes. The damp dark where centipedes live is a paradise for fungus, and fungus is death to an egg. So the centipede mother does more than guard her clutch. She grooms it. Using her mouthparts and legs, she continually cleans the eggs, licking and tending them to remove the spores and microbial growth that would otherwise take hold and rot the whole clutch. It is meticulous, constant work. Leave the eggs untended for long in that moist environment, and fungus would bloom across them. The mother's grooming is what holds it back, an ongoing battle fought egg by egg through the weeks of care. This is a far more active form of parenting than mere guarding. The mother is not just a wall but a caretaker, managing the microscopic dangers that no shield could stop, applying secretions and constant attention to keep the clutch clean and viable. Experiments have shown how essential this is. Eggs separated from the mother often succumb quickly to fungal growth that her grooming would have prevented. Picture the patience of it, a predator that catches snakes, spending hour after hour gently turning and cleaning each egg in the dark, fighting an enemy too small to see. It is the unglamorous, essential labor of keeping life alive in a world that wants to decompose it. The centipede mother fights that war with her own body and attention, and the survival of her young depends on her winning it egg by egg, day after day, until they hatch. We met the cave ceiling hunt as a horror, a giant centipede snatching bats from the air. Look again and see the strategy in it. The centipede cannot fly, cannot chase a bat through open air. So it analyzed in the long calculus of evolution and individual experience, where bats are predictable, the cave ceiling, the flight path, the moment of passing close to the rock, and positioned itself precisely there. It anchors only its rear legs, freeing the rest of the body to strike into open space, and it commits to hanging over a void to reach prey that no ground-bound hunter could touch. The strategic depth is striking. The centipede has identified an opportunity its body alone could not seize and engineered a way to seize it anyway, turning the cave's architecture and the bat's own habits into the tools of the hunt. It is problem-solving made flesh, recognizing that the prey is reachable only at a particular place and moment, and arranging to be exactly there. Picture the deliberation hidden in that posture. The choice of spot, the anchoring grip, the patience to wait in position, the timing of the strike, none of it is simple. The same behavior that frightened us as a feat of horror is examined closely, a feat of intelligence, a hunter expanding its reach into the impossible by reading its world and exploiting it. The bats fly the same path every night. The centipede learned the path and waits. The centipede's world is a maze of tunnels, cracks, and tight, dark passages, and it navigates this labyrinth almost entirely by touch. With little or no sight, the animal threads through the underground network by feel, antennae reading the way ahead, body sensing the walls of each passage, legs finding purchase on every surface. It moves through spaces it cannot see with a confidence that comes from a different way of knowing the world, one built on contact rather than vision. This is navigation as a tactile art. The centipede maps its territory not as a picture, but as a felt landscape of textures, widths, and turns, remembering and reading the passages through the touch of its many senses. A tunnel too narrow for sight is no obstacle to an animal that finds its way by pressing against the walls. The flattened body we met earlier serves this perfectly, letting the centipede pour through gaps and follow passages that would stop around a creature cold. Picture moving through a pitch-black warren of tunnels, never lost, always certain of the way, guided entirely by the feel of the walls and the memory of the route. That is the centipede's daily commute through the world beneath our feet. It is a kind of spatial competence we rarely credit such a simple-seeming animal with a creature that holds the layout of its underground territory in a form built from touch, and moves through the lightless maze as easily as we cross a familiar room with the lights on. The centipede is dangerous, but it is not reckless. Faced with a threat, the animal makes a choice, flee or fight, and the choice is not random. A smaller threat, or one met with the advantage of surprise, may draw a defensive strike, the forcipules raised and ready. A larger predator, or one that catches the centipede exposed, more often triggers flight, the animal pouring itself into the nearest crack at full speed. The centipede weighs its odds in whatever simple terms its nervous system allows and acts accordingly. This is risk assessment, the same calculation every animal that wants to survive must make. The centipede is well armed, but its venom is precious, and a fight is dangerous even when you win. So the animal does not fight when fleeing will do. It saves its weapon for the moments that demand it and runs from the rest. The flattened body, the speed, the cracks it can vanish into, all of these make flight a strong option, and the centipede takes it when the math favors escape. Picture a hunter that knows exactly how dangerous it is, and precisely because it knows, picks its battles, striking when the odds are good, vanishing when they are not. There is a kind of intelligence in that restraint. The reputation paints the centipede as an aggressor, all venom and attack. The reality is a careful animal that fights only when it must and otherwise simply disappears into the dark before the threat can close. Hunting armed prey is a delicate business, and the centipede handles it with disturbing skill. A scorpion has a sting, a spider has fangs, a snake has teeth. To eat them, the centipede must subdue each one without taking the wound that those weapons can deliver, and it does again and again. The technique lies in the strike sequence, and the coil sees the dangerous prey. Pin its weapon before it can be used, and inject the venom that drains the fight away before the sting or the bite can land. The centipede grips a scorpion in a way that controls the tail. It seizes a snake behind the head where the fangs cannot reach. It pins a spider before the fangs can find a target. This is prey handling as a learned and evolved competence, a careful management of risk in the very act of killing. The centipede does not simply bite and hope. It positions it, controls it, neutralizes the prey's weapon as part of the capture. Picture a hunter that must disarm its victim in the same motion that kills it, and does so against opponents whose weapons could kill the hunter in turn. The margin for error is thin, and the centipede works within it routinely. It is one more piece of evidence that far more is happening in the strike than blind aggression, a real management of danger, a handling of armed and lethal prey that keeps the centipede safe while its meal is subdued. The hunter takes the venomous and survives because it knows exactly how to hold them. The centipede survives not only by being dangerous, but by being absent. Its whole way of life is organized around not being caught hunting at night, when many predators sleep, staying under cover by day, vanishing into cracks at the first sign of danger, reading the ground and air for threats long before they arrive. The animal's defenses begin not with the bite but with never being found. Timing and cover are its first armor. By keeping to the dark hours and the hidden places, the centipede simply removes itself from the path of most things that would eat it. The daylight predators rarely see it. The open ground hunters rarely meet it. The creature lives in a temporal and spatial niche that keeps it out of reach. When a threat does find it, the speed and the cracks take over, the centipede flowing out of danger before the attack can land. And only when escape fails does the venom come into play, the last line rather than the first. Picture a creature that survives mainly by never giving its enemies the chance awake when they sleep, hidden when they hunt, gone before they strike. The forcipules are the dramatic defense, the one we remember, but they are rarely needed because the centipede's first strategy is simply to be somewhere its predators are not. It is the quiet, unglamorous side of survival, not the weapon, but the timing and the cover that mean the weapon seldom has to be drawn at all. The centipede's hindmost legs are a Swiss Army tool, and defense is one of their sharpest functions. We have seen them sweep the space behind the body like a second set of antennae and mimic the head to misdirect an attacker. They do more still. In many species, these rear legs are thickened, spined, or shaped to grip, and the centipede uses them to pinch to anchor, to fend off a predator coming from behind. Raised and waved, they become a bluff, a display that makes the tail look as threatening as the head, freezing an attacker in indecision. The animal turns its least armed end into a convincing imposter of its most dangerous one. A predator that hesitates, unsure which end carries the venom, gives the centipede the instant it needs to bring the true forcipules around or to flee. The bluff buys time, and time is survival. In some species, the rear legs can even grasp and hold, turning a defensive posture into a countergrip on whatever attacks. Picture an animal that has weaponized its own tail, with a lie presenting a false head so persuasive that predators commit to the wrong end. It is a remarkable economy of design, the same legs serving as sensors, as decoys, and as defensive tools depending on the moment. The centipede wastes nothing. Even the legs at the very back of its body, far from the venom, and the eyes have been pressed into the work of keeping the animal alive, sensing, bluffing, and fighting all at once. For an animal that lives or dies by moisture and warmth, finding the right spot is everything, and the centipede reads temperature with care. It senses the gradients in its environment, the cool damp of deep soil, the warmth of a sun-baked stone, the chill of open night air, and uses them to navigate toward the conditions it needs. A centipede drying out moves toward cooler, moister ground. One too cold seeks the warmth that keeps it active. This thermal sense guides the animal to shelter, helping it find the narrow band of conditions where it can survive. The stakes are real. We have seen how fast the centipede loses water, how bound it is to damp and shadow. Reading temperature is part of how it stays within its safe zone, sensing where the favorable microclimate lies and moving there before the dryness or the cold can harm it. The whole hidden world beneath a log or a stone is a landscape of gradients, warmer here, wetter there, and the centipede navigates it by feel, settling always into the pocket that suits it best. Picture an animal that reads the invisible map of temperature and humidity laid across the ground, threading toward the one spot where it can thrive. It is another quiet competence behind the simple eyes, another sense feeding the centipede's constant management of its own fragile survival. The hunter that frightens us is underneath a creature carefully reading the warmth and chill of its world, always seeking the shelter that keeps the water in and the cold out. The centipede will eat its own kind, and the choice is not madness, but arithmetic. When prey is scarce, when a smaller centipede crosses the path of a larger one, when a rival occupies contested ground, the centipede may strike and consume another centipede without hesitation. It is a solitary competitive animal, and another of its species is depending on the circumstances, either a rival or a meal. Cannibalism among centipedes follows a cold logic of size and opportunity. The larger takes the smaller, the strong takes the weak. An available body is calories, whatever shape it wears. This is part of why centipedes are largely solitary, why they keep their distance, why even mating must be approached with a certain caution. Get the calculation wrong, and a potential partner becomes a predator. The mother who guards her eggs so devotedly may, in another season and another context, eat a centipede no different from her own offspring. There is no contradiction in it from the animal's point of view, only circumstance and calculation. Picture a creature for whom its own kind is just another entry on the menu, weighed by size and hunger like any other prey. It is unsettling to us who carry strong instincts against it, but for the centipede, it is simply efficient, a refusal to waste available food on the grounds of kinship. The same venom and speed that take the cricket take the rival centipede, and the animal that wins the encounter eats regardless of what it has eaten. To move as fast as a centipede is to face a problem of perception as much as muscle. The animal that strikes and flees in fractions of a second must also sense, decide, and coordinate within those same fractions, processing a world that is rushing past at a pace its small nervous system must somehow keep up with. Speed is not just a physical feat, it is a cognitive one. The centipede must detect prey, judge distance, trigger the strike, and steer the whole rippling body all faster than we can follow. This demands a nervous system tuned for velocity, able to take in sensory information and convert it to action with almost no delay. The distributed design helps, sharing the processing load down the body rather than funneling everything through one slow central point. Local control means local speed. Each region of the animal can respond to its own signals without waiting for orders from a distant brain. Picture the challenge of acting meaningfully in a world that, to you, moves in a blur, sensing and deciding and coordinating dozens of limbs all within an instant. The centipede solves it constantly, every strike and every escape a small triumph of fast processing. We tend to imagine that quick reflexes require little thought, that speed and simplicity go together. The centipede suggests otherwise. Its velocity is built on a nervous system genuinely good at handling a fast world, taking in information, deciding and acting in windows of time so short that to us the whole event is over before it has begun. Fleeing is not just running, it is running the right way, and the centipede manages both at once. When it bolts for cover, the animal does not simply move fast, it moves with purpose, maintaining its orientation, steering toward the crack or crevice that means safety, even as its whole body flows at top speed. To run flat out while still navigating, still reading the environment, still aiming for the one gap that offers escape is a coordination feat layered on top of the already remarkable feat of running on 100 legs. The escape must be both fast and accurate. A centipede that ran blindly would flee into a dead end or into the open. Instead, it keeps its bearings using the senses we have explored, touch, vibration, the felt map of its territory to guide the sprint toward refuge. The same antennae and rear legs that hunt and defend now help steer the flight, reading the way ahead and behind even at full speed. Picture an animal pouring itself across the ground in a blur, dozens of legs firing in perfect sequence, and through all that frantic motion holding a steady aim at the safe dark slot in the wall. It does not lose its way in the rush. The coordination that lets it move so fast also lets it move so precisely, the speed and the steering bound together into a single controlled escape. The centipede flees the way, it hunts fast-oriented and exact, never sacrificing direction for pace, arriving at safety, because it never stopped knowing where safety was. For all that we have learned, the centipede remains a frontier. Recent research keeps overturning the old picture of a simple, reflexive killer, revealing an animal of unexpected complexity, sophisticated venom, careful prey handling, real maternal care, flexible hunting strategy, genuine problem-solving in the hunt. Scientists studying these creatures with modern tools find more behind those simple eyes than anyone once assumed. New work on centipede venom uncovers cocktails of startling chemical complexity, dozens of novel compounds per species, some with potential value to medicine. Studies of their behavior document decision-making, learning, and care that complicate the old image of a pure killing machine. And researchers still debate the basic puzzles, the odd leg rule, the deep evolutionary relationships, the full workings of the venom, meaning the centipede is far from a closed book. There is a humility in this for us. We have shared the planet with centipedes for the whole of human history, and only now, with the tools of modern science, are we beginning to grasp how much is happening inside them. Picture how much remains unknown about an animal so common we find it on our bathroom walls, and yet whose venom we have not fully mapped, whose behavior still surprises us, whose oldest rules we cannot fully explain. The centipede teaches a lesson worth remembering: that the familiar can stay mysterious, that an animal underfoot for millions of years can still hold secrets, and that the work of truly understanding it has only begun. The centipede's life begins underground in the dark, as an egg. The mother deposits her clutch in a hidden chamber, a burrow, a pocket in the soil, a sheltered space beneath a stone, and there, in the damp and the dark, the next generation begins. This underground nursery is the safest place she can find, hidden from predators, buffered from the dry air, held at the steady moisture the eggs need to survive. It is a fitting beginning for an animal that will spend its life in the hidden world. The centipede does not start in the open or the light. It starts buried in a small, dark chamber, tended by its mother, the egg, a pale promise in the soil. The choice of nursery matters enormously. Too dry, and the eggs desiccate. Too exposed, and predators find them. Too foul, and fungus takes them. The mother selects and maintains the chamber with care, and her weeks of guarding and grooming, which we have already seen all unfold here in this small hidden space. Picture the nursery, a tiny pocket in the earth, dark and damp, a cluster of eggs at its center, the mother coiled around them. The whole future of a centipede held in this buried room. From here in time, the young will emerge to begin their own lives in the soil and the leaf litter. But first there is only this: the egg, the chamber, the dark, and the patient mother, the quiet underground beginning of one of the planet's oldest hunters. How a centipede gets its legs is a tale of two strategies, and the difference splits the group in two. Some centipedes are born already, carrying their full complement of segments and legs. They hatch complete, and growth simply makes them larger. This is one path. Others hatch with far fewer segments than they will eventually have, and add more with each molt, the body lengthening leg pair by leg pair as the animal develops toward its adult form. Scientists call these two paths epimorphosis and anamorphosis, and the choice between them runs deep in centipede biology, dividing the major groups by how they build their bodies. The contrast is striking. In one lineage, the young is a miniature of the adult, all its segments present from the first. In the other, the animal assembles itself over time, growing legs. As it grows up, each shedding of the skin, adding new segments until the final count is reached. Picture two ways of building a long body: cast it complete from the start, or extend it piece by piece across a series of moltings. Centipedes do both, depending on the lineage, and the split is one of the fundamental divisions in how these animals come to be. It connects back to the odd leg rule, to the segmented design, to all the deep questions of how the centipede's body is made. The way an individual gains its legs echoes the way the whole group is organized, and in that small developmental choice lies a window onto the centipede's ancient and divided family tree. For the centipedes that add segments as they grow, reaching the full adult leg count is a gradual journey. The young animal begins life shorter with fewer legs than it will eventually carry, and only through a sequence of molts does it slowly extend toward its final form. Each shedding adds a little more new segments, new legs, until at last the animal reaches the complete count it will keep for the rest of its life. It is growth measured not just in size but in number, the body accumulating its parts over time. This slow path is a different way of becoming than we are used to. We are born with all our limbs and simply grow larger. These centipedes are born incomplete and assemble themselves as they go, gaining their full anatomy across the early stages of life. There is a patience to it, a building up of the body in installments, each molt a small step toward the finished animal. Picture a creature that starts life with only part of itself and earns the rest through the dangerous repeated act of molting, growing into its full count of legs, the way a structure rises piece by piece. By the time it reaches adulthood, the centipede carries the complete odd-numbered set it was always destined for, but it arrived there gradually, segment by segment, molt by molt. The journey from a short-bodied juvenile to a fully legged adult is one of the quiet wonders of centipede development, a body completing itself in stages across the early chapters of a long life. Most people imagine a creature like this living and dying in a single season the way so many insects do. The centipede defies that expectation. These animals can live for years, several years in many species, and longer still in some of the larger ones, which may persist for half a decade or more. The centipede is not a brief flicker of life, but a sustained presence, returning season after season, growing slowly, hunting for a long time. This longevity reshapes the picture. The centipede on your wall is not a mayfly here and gone. It may have been hunting the dark of your home for years, and may continue for years more. The slow growth, the repeated molting, the gradual building of the body, all of it unfolds over a span far longer than the fleeting lives of most small invertebrates. A long life means a long career as a predator, time to learn a territory, to grow large, to raise multiple generations of young. Picture an animal we dismiss as a transient pest, actually outliving many of the creatures we consider far more substantial. Persisting quietly in the soil and the cracks for years on end, the centipede plays a long game. It does not burn fast and die young. It endures growing and hunting across years, a patient, long-lived predator hidden in the places we never look. The brevity we assume is simply wrong. Beneath the leaf litter and behind the baseboards, these ancient hunters are living lives measured in years, not the weeks we would casually grant them. Growth for the centipede comes only through surrender. Locked inside its rigid exoskeleton, the animal cannot simply expand. To grow larger, it must shed the old shell entirely and emerge anew. And it does this not once but many times across its long life, each molt a step up in size, each one a return to that brief, dangerous window of softness and vulnerability. The centipede's whole growth is a series of these moltings, a life punctuated by repeated sheddings of its armor. We met molting earlier as a moment of peril, the fierce hunter rendered helpless while its new shell hardens. Now see it as the engine of the centipede's development, the only way it grows, the mechanism behind its slow climb toward adult size, the process that in some lineages adds the very segments and legs that complete the body. The animal pays the price of vulnerability again and again because there is no other path to growth. Picture a creature that must repeatedly throughout its years abandon its protection and rebuild it, larger gambling each time on surviving the soft hours, all so it can become a little bigger. It is growth as a recurring ordeal, a life spent periodically casting off and remaking the self. Each successful molt leaves the centipede larger, sometimes more complete, and ready to hunt again until the next one comes due. The armor that defines the centipede also constrains it to this rhythm, a long life measured out in the repeated, perilous, necessary act of shedding everything and starting the shell again. There is a moment when the deadliest hunter on the forest floor is utterly helpless, and it comes right after the molt. The instant the centipede crawls free of its old shell, its new cuticle is soft, pale, and yielding its armor, not yet hardened, its forcipules too soft to strike, its whole body fragile and exposed. For a window of hours, the predator is defenseless, unable to fight, slow to flee, vulnerable to anything that finds it in the dark. It is the most dangerous time in a centipede's life. Everything that makes the animal formidable, the venom, strike the armored body. The speed is temporarily gone, stripped away by the very process that lets it grow. The centipede must hide and wait motionless in some sheltered pocket, while its new shell slowly stiffens and its weapons regain their strength. During these hours, a predator that would never dare approach a hardened adult could take the centipede with ease. Picture the fearsome hunter we have built up across all these facts, suddenly naked and weaponless in the dark, waiting in hiding for its body to turn hard again at the mercy of anything that stumbles upon it. The contrast is stark and humbling. The same animal that hangs from cave ceilings and disarms scorpions must, every time it grows, pass through these hours of complete vulnerability. It survives them by hiding well, by choosing a safe place to molt, by staying utterly still until the danger passes and the armor returns. The hunter briefly becomes the most catchable thing in the dark. Set the centipede beside the insects it often lives among, and its lifespan stands out. Many insects live fast and die young, weeks a season, a single summer, their lives a brief, intense burst of growth and reproduction. The centipede plays a different game entirely. Living for years, growing slowly, reproducing across multiple seasons, it is the tortoise among hares, the patient, long-lived predator in a world of brief insect lives. This longevity gives the centipede a different kind of existence. Where a fast-living insect must cram everything into a few short weeks, the centipede has time to grow large, to master a territory, to hunt across years, to raise young more than once. It is not racing against an early death. It is settling in for the long haul. The slow, patient pace runs through everything about the animal, from its gradual growth to its unhurried ambush hunting, to its years-long career in the dark. Picture two strategies for life, playing out on the same forest floor, the insect blazing through its single season, and the centipede beneath it, quietly outlasting generation after generation of its faster neighbors. The centipede's long game is part of what makes it such a persistent presence, always there, always hunting, a fixture of the hidden world rather than a seasonal visitor. It bets on endurance over speed of life, on lasting rather than rushing. And in the damp dark where it lives, that bet pays off, the centipede persisting, year after patient year, while the brief lives around it flare and fade. Beneath a single patch of ground lies a centipede's entire world, and that world is larger and more complex than we ever imagine. A centipede holds a territory in the soil and leaf litter, a network of tunnels, hiding spots, hunting grounds, and shelters that it knows, intimately navigates by touch, and defends against rivals. To us, it is a square of dirt. To the centipede, it is a whole landscape, mapped and memorized, the stage on which its long life plays out. The scale is a matter of perspective. What looks to us like an undifferentiated patch of forest floor is to the centipede a rich and varied terrain, this crack for shelter, that tunnel for hunting, this damp pocket for the dry days, that route to the surface for the night's foraging. The animal carries a felt map of all of it, built from the touch and vibration and chemistry we have explored. Picture the hidden geography beneath a single footstep, the passages and chambers and hunting trails of a creature living out years of its life in a space we would step over without a glance. The centipede's territory is its whole universe, and within that small patch it lives a complete predatory life, hunting, hiding, growing, defending, raising young. We walk over 100 such worlds without knowing they are there. Each one belongs to an ancient hunter that knows every inch of its small, dark domain, holding and working its territory underfoot, with a competence and persistence entirely out of scale with how little we notice it. Look down at a healthy patch of forest floor, and you are standing over a hidden multitude. Centipedes are far more abundant than most people ever realize. A single stretch of rich woodland soil can harbor a remarkable density of them, hunting the layers of leaf litter and earth, an entire population of predators packed into the ground beneath your feet. We see one occasionally and think them rare. In truth, they are everywhere in numbers that would astonish us if we could see through the soil. The forest floor is one of the most densely populated hunting grounds on the planet, and centipedes are among its key predators, present in abundance throughout the litter and the upper soil. Each one holds its small territory. Together, they form a hidden layer of predation woven through the ground, controlling the insects and other small creatures that share the dark. Picture the soil beneath a single tree teeming with these hunters, far more of them than the rare surface sighting would suggest, an unseen population pursuing its prey through the buried world. The abundance is part of what makes the centipede ecologically important, a point we will come to. There are simply so many of them working the leaf litter that their collective effect on the populations of smaller creatures is substantial. We imagine the centipede as an occasional intruder. The reality is a vast, hidden presence. A multitude of ancient hunters spread through the ground. We walk on each, in its territory, all together, forming one of the busiest and least seen predatory communities on Earth. The centipede is not one animal but thousands. Scientists have described thousands of distinct centipede species spread across the globe, and the true number is certainly higher. Many more remain unnamed, undiscovered, waiting in the soils and forests of the world. From the tiny soil dwellers a few millimeters long to the giant cave hunters longer than a hand, the variety within this single group is staggering. This diversity is a measure of the centipede's deep success. A body plan does not radiate into thousands of forms unless it works extraordinarily well, unless it can be adapted again and again to new habitats, new prey, new ways of life. The centipede has done exactly that, taking its ancient design, the segmented body, the venom claws, the many legs, and reshaping it into thousands of variations on a theme. Each species is a different answer to the question of how to be a centipede in a particular place. Picture the range hidden within that single familiar word, hunters of every size, color, and habit, living in deserts and rainforests, in caves and high mountains, in soil and leaf litter, across nearly the whole planet. They are united by the deep shared design and divided into thousands of distinct lives. The centipede on your wall is one representative of a vast and varied family, an ancient lineage that has diversified into a sprawling array of forms while keeping the same essential blueprint. The diversity is the proof of the design's power, one good idea elaborated into thousands of living species, each one a centipede, none of them quite the same. The span of the centipede family is almost hard to believe. At one end stand species so small they are barely visible, a few millimeters of pale body threading through the soil. At the other stand giants like Scolopendra gigantea, stretching longer than a human hand, heavy-bodied predators that take mice and bats and snakes. Between these extremes lies every size in between, a continuous range from the nearly microscopic to the genuinely formidable. To hold both ends of that range in mind is to grasp how flexible the centipede's design truly is. The same basic body plan segments, legs, forcipules, works at the scale of a grain of rice and at the scale of a small snake, scaled up and down across orders of magnitude. The tiny soil dweller and the giant cave hunter are built on the same blueprint, separated only by size and the adaptations that size demands. Picture the smallest centipede, a sliver of life almost too small to see, and then the largest, a dark, gleaming length that could coil around your wrist and recognize them both as the same kind of animal. The modular body makes this possible. Add or subtract segments, scale the parts, and the design holds at nearly any size. It is one of the marvels of the group, this enormous range packed into a single shared form. From the millimeter to the foot, the centipede demonstrates how far one good design can stretch the same hunter realized at scales so different they hardly seem to belong to the same animal at all, and yet they do. Geography sorts the centipedes by size and temperament. In the warm, wet tropics live the giants, the large, powerful Scolopendra, and their kin thriving in the heat and humidity, growing to formidable lengths, hunting substantial prey. In the cooler temperate regions live smaller, more modest centipedes, the soil dwellers and house centipedes that work the leaf litter and the damp corners of our homes. The map of the centipede is in part a map of warmth and moisture. The tropics, with their year-round heat and abundant damp, support the largest and most spectacular species animals that need the warmth to fuel their size and activity. The temperate world, cooler and more seasonal, hosts smaller centipedes adapted to its gentler conditions, hunters scaled to a less generous climate. The pattern reflects the deep tie between the centipede and moisture and warmth that we have traced throughout. Where conditions are richest, the centipedes grow largest. Picture the contrast. A giant tropical hunter, the length of a hand prowling a humid rainforest floor, and a modest temperate centipede, the length of a finger threading through the cool soil of a northern wood. Both are centipedes. The climate has shaped them to different scales. It is why the truly enormous centipedes belong to the tropics, why the temperate dweller rarely matches their size. The warmth and the wet of the equatorial world give the giants the conditions they need to reach their full astonishing dimensions, while their temperate cousins make their living smaller and quieter in the cooler latitudes. The centipede has pushed into places that should be uninhabitable, and it endures there. In the lightless depths of caves live centipedes that have abandoned eyes, entirely hunting in total permanent darkness, perfectly at home where the sun has never reached. High on cold mountains near the limits of where life can persist, other centipedes survive the thin air and the chill, hunting in conditions that would defeat most of their kind. The group has found a way into the planet's harshest corners. These survivors show how far the centipede's design can be stretched to meet extremity. The cave dwellers, sealed in darkness, lean entirely on the touch and chemistry and vibration senses we have explored, their blindness no handicap in a world without light. The high-altitude species endure cold and scarcity, adapted to a hard, sparse life near the edge of the possible. Each is the centipede's ancient blueprint, pushed to an extreme environment and made to work. Picture a hunter thriving in the absolute black of a deep cave, and another clinging to life high on a frozen peak, both centipedes, both surviving, where so little else can. It speaks to the resilience and adaptability of the lineage, its capacity to colonize the marginal and the extreme. The centipede is not confined to comfortable forest floors. It has reached into the deep, dark, and the cold heights, and in each it has found a way to keep hunting. Wherever there is moisture enough and prey enough, even in the planet's most forbidding corners, some centipede has very likely found a way to make a living there. Some centipedes glow. In certain species, the body produces a faint, cold light, a soft bioluminescence that shines out of the darkness where the animal lives. It is a strange and beautiful trait in a creature better known for venom and speed, a quiet glow rising from the forest floor, the centipede briefly visible as a thread of pale light in the dark. Why they glow is not fully settled. Bioluminescence in the animal world serves many purposes: warning attraction, camouflage by counter-illumination, and scientists still work to understand exactly what the glow does for the centipedes that produce it. It may be a warning signal, the light advertising the animal's danger in the dark, much as bold color does in the light. It may serve some other function not yet understood. The uncertainty is part of the wonder. Picture coming upon a centipede at night and finding it softly luminous, a faint living glow moving across the ground, an unexpected beauty in an animal we have learned to fear. It complicates the picture once more, adding a note of quiet marvel to the catalogue of venom and speed and hidden intelligence. The glowing centipede is a reminder that these animals still hold surprises, that even their appearance can startle us with something lovely and unexplained. In the deep dark where the centipede lives, some of them carry their own faint light, a soft glow rising from the leaf litter, beautiful and mysterious. Its full purpose still among the many things about the centipede we have yet to understand. Water is the thread that runs through the entire centipede life, from the first egg to the last molt. The eggs need damp to survive. The freshly molted body needs moisture to harden. The adult needs humidity every hour to replace the water that leaks ceaselessly from its body. At every stage, in every season, the centipede's life is organized around the presence of water, bound to the damp places that keep it alive. We have met this dependence again and again, the poor waterproofing, the rapid drying, the exile from sunlight and open ground. Now see it whole as the single constraint that shapes the entire arc of a centipede's existence. The choice of the underground nursery, the nocturnal hunting, the hiding under logs and stones, the retreat into moist soil, all of it traces back to the need for water. The centipede cannot escape this need. It follows the animal from birth to death, governing where it can live and when it can move. Picture a creature whose every life stage is chained to moisture, never free of the danger of drying out, always seeking the damp that sustains it. From the egg in its humid chamber to the adult threading the wet soil, the centipede lives within the narrow band where water is plentiful enough to survive. It is the great limit on the animal, the constraint beneath all its power, the fearsome hunter that nonetheless cannot stray far from the wet, bound at every moment of its long life to the moisture that keeps it from drying to nothing in the open air. The ground beneath us is alive in ways we rarely consider, and the centipede is one of its busiest residents. Just below the surface, in the leaf litter, the upper soil, the dark damp layer where so much life concentrates, centipedes hunt in numbers and with an activity that would astonish anyone who could watch it. There is a whole hidden ecosystem there, and the centipede is one of its principal predators, working the underground night shift in abundance. This hidden abundance is part of the centipede's quiet importance. We see the surface world and imagine that is where life happens, but beneath our feet lies a teeming layer of predation and consumption, and centipedes are woven all through it, hunting the small creatures of the soil in vast unseen numbers. The richness of life just below the surface depends on hunters like these predators that keep the populations of smaller animals in balance. Picture the soil under a single field or forest as a busy, crowded, predatory world, centipedes flowing through its dark passages in numbers we never glimpse, hunting constantly in the layer just beneath the one we walk on. It is a reminder of how much life exists out of sight, how thin the slice of the world we actually perceive. The centipede belongs to that hidden abundance, one of the many hunters of the underground present in the dark, damp layer in numbers far beyond what the rare surface sighting reveals. Below every footstep, the unseen hunt goes on. Return at the end of this wandering to the simplest, astonishing thing about the centipede, those many legs moving as one. 40, 80, 100, 300 limbs, all firing in coordinated waves, all flowing together into a single smooth motion across the ground. After everything we have learned about the neural feat behind it, the wonder only deepens. That so many separate parts can move in such perfect unison is a small miracle of biology playing out every time the animal walks. There is a beauty in it that the centipede's fearsome reputation tends to hide. Slow the motion down and watch the waves ripple down the body, each leg lifting and falling in its turn, the whole creature flowing like something liquid across the surface. It is mesmerizing, a coordination so seamless that the dozens of legs read as one continuous motion rather than many. Picture the sheer organization required, the distributed nervous system, orchestrating every limb, the timing that keeps them from ever colliding, all of it running automatically, endlessly, every moment the centipede moves. We began in dread, fearing this animal for its venom and its speed. We arrive here at something close to admiration, watching all those legs move as one, and seeing not a monster but a marvel of living engineering. The same body that frightens us is looked at with open eyes, one of the most elegantly coordinated machines in all of nature. 100 legs, a single flowing motion. The ancient centipede pouring itself across the ground in the seamless, hypnotic, beautiful gait that no engineer has ever quite managed to match. The centipede makes a living in places that defeat nearly every other predator. The deep soil, the lightless cave, the high cold mountain, the thin cracks between stones, these are hunting grounds most predators cannot use, and the centipede works them with ease. Where there is no light, no open space, no easy passage, the centipede goes anyway and finds prey where almost nothing else can reach. This is part of what has carried the lineage so far through time. By specializing in the hidden, narrow, dark places of the world, the centipede claimed a hunting ground with little competition, a realm of its own, where its particular gifts, the blindness that does not matter, the flattened body, the touch, and chemistry senses the venom strike all come into their own. Other predators need light or space, or both. The centipede needs neither. Picture a hunter thriving in the very places that turn other predators away, working the dark cracks and buried passages and lightless depths as comfortably as a hawk works the open sky. It is a different kind of dominion, won not by power in the open but by mastery of the hidden. The centipede did not have to outcompete the great surface predators. It simply went where they could not follow and made that hidden world its own. In the seams and depths and dark, it hunts almost alone, an ancient predator perfectly fitted to the places the rest of the living world overlooks or cannot enter. For all that the centipede shares our world, it lives almost entirely beyond our notice. Its life unfolds in the dark and the damp at night, underground in the hidden places we never look, and so the vast majority of everything a centipede ever does happens completely out of human sight. We catch the rarest glimpse, a streak across the floor, a shape under a lifted stone, gone before we fully register it. The rest, the whole of its long life, we never see at all. There is something humbling in that. An animal lives for years, just beneath and beside us, hunting, growing, molting, raising young, fighting, fleeing, and we witness almost none of it. The hidden world the centipede inhabits is in a sense the larger part of the living world. The part that happens where we cannot watch, and the centipede is one of its countless unseen residents. Picture all the drama we have traced across these facts. The cave-ceiling hunts, the maternal vigils, the strikes and escapes and molts playing out endlessly in the dark, entirely unobserved year after year. The centipede asks for no audience. It lives its complete and complex life in the places our eyes never reach, and only by chance and effort do we learn anything of it at all. As we turn now toward what the centipede means, its deep past, its place in the world, the questions it still poses, it is worth holding on to this. That nearly everything this ancient animal is and does happens in a hidden world we have only just begun to see into. Go back to one of the most important moments in the history of life, when animals first left the water and ventured onto dry land, and the centipede's ancestors were among them. The early relatives of today's centipedes were among the first animals ever to walk on land, pioneers of the terrestrial world, present near the very beginning of life's great move out of the sea. This is the deep weight of the centipede's lineage. It is not a recent animal, but an ancient one, descended from creatures that helped open the land to animal life hundreds of millions of years ago. When the continents were barren and the first living things were just beginning to colonize, the ground centipede-like animals were already there, already hunting, already walking on many legs across the new dry world. Picture the empty early land, no forests, no flowers, no familiar life. And among the first animals to move across it, the ancestors of the centipede predators almost from the start. The centipede we find on our walls is the inheritor of that ancient pioneering, a living descendant of some of the first animals to make a life on land. To hold a centipede in your gaze is to look at a lineage that reaches back to the very dawn of terrestrial animal life, an unbroken line of hunters stretching from those first landwalkers to the creature in the dark beneath us now. Few animals carry so deep a history. The centipede was there at the beginning, and it is still here. The centipede's ancient story is written in stone. Fossils of centipedes and their close relatives reach back hundreds of millions of years, preserving the same essential body, the segments, the legs, the predatory form, across spans of time almost too vast to grasp. These fossils confirm what the living animal suggests, that the centipede's design is staggeringly old, established deep in the past, and carried forward little changed ever since. To look at one of these fossils is to see the centipede's blueprint already complete hundreds of millions of years ago, the same long, segmented hunter we know today pressed into ancient rock. The design did not need to change much because it worked so well from early on. Across all the upheavals that stone records, the extinctions, the shifting continents, the transformations of climate and life, the centipede's form endured, recognizable then and recognizable now. Picture the fossil, a centipede laid down in rock hundreds of millions of years before any human existed, its body unmistakably that of a centipede still. We are not looking at a distant ancestor that merely led to the centipede. We are looking at a centipede, or something so close it hardly matters, alive, in a world unimaginably far from ours. The fossils make the deep time real, anchoring the centipede's antiquity in physical evidence. The animal in the dark beneath us tonight belongs to a lineage whose form has persisted, proven, and unbroken. Across a stretch of time, the fossils let us almost begin to comprehend hundreds of millions of years of the same successful hunter. The centipede belongs to the great sprawling family of the arthropods, the vast group that includes the insects, the spiders, the crustaceans, and more. But it occupies an ancient and distinctive branch of its own. Centipedes are myriapods, the many-legged arthropods, a lineage that split away deep in the past and followed its own long path. Separate from the insects and the arachnids we more often think of. Understanding where the centipede sits in this family tree is part of understanding what it is. It is not an insect despite a casual resemblance. Insects have 6 legs and a different body plan, and they sit on a different branch. The centipede's many legs and segmented body mark it as something older and distinct, a representative of a separate ancient radiation of arthropod life. Scientists still work to map the precise relationships, debating exactly how the myriapods connect to the other great arthropod groups. Picture the arthropod family tree as a vast branching structure and the centipede on its own deep limb, distinct from the insects, the spiders, the crustaceans, carrying forward an ancient way of being an arthropod. Its place on that tree tells a story of early divergence and long independent survival, a lineage that found its form early and has held a branch of the tree ever since. The centipede is a reminder of how varied and how old the arthropods truly are, a distinct and ancient line within the most successful group of animals on Earth, still here, still hunting, still holding its deep place in the family tree. The centipede earns its place in the world by what it removes. As a predator of insects and other small creatures present in the soil and leaf litter in great abundance, the centipede helps control the populations of the animals it hunts, including many we regard as pests. The house centipede in the basement hunts cockroaches and silverfish. The soil centipedes of the forest floor consume vast numbers of small invertebrates. Collectively, they are a significant force in keeping those populations in check. This is the centipede's quiet service to the ecosystems it inhabits and to us. Predators that consume pests perform a real function, suppressing the numbers of creatures that would otherwise multiply unchecked, contributing to the balance of the living communities they belong to. The centipede, abundant and constantly hunting, is one of these regulating forces working unseen in the soil and the dark corners. Picture the populations of small insects that the centipedes of a single forest floor consume across a year, an enormous, invisible pressure that helps shape the whole community of life in the ground. We tend to see only the centipede that startles us and miss the service it performs. But the animal is an important predator woven into the food web, helping to control the creatures it eats. The same hunter we fear is also a regulator, a check on the populations of pests and small invertebrates, doing in the dark the unglamorous essential work of predation that helps keep the hidden ecosystems of the soil in balance. The centipede stands in the middle of the food web, fierce from one direction and vulnerable from the other. To the insects and small creatures it hunts, it is a deadly predator. To the birds, reptiles, amphibians, and mammals that hunt it, in turn, it is prey. The same animal that strikes terror into a cricket is itself the target of larger hunters, occupying a middle station in the great chain of eating that connects the living world. This dual role is part of the centipede's ecological importance. It does not only consume, it is also consumed, passing the energy it gathers from its prey upward to the predators that eat it. In this way, the centipede is a link, a connector in the food web, channeling the energy of the small soil creatures it hunts into the bodies of the larger animals that hunt it. Picture the centipede at the center of two arrows, one pointing down to the prey it kills, one pointing up to the predators that kill it, a hub in the flow of energy through its ecosystem. We have spent much of this account on the centipede as predator, on its venom and speed and lethal skill. But it is also a meal, a part of the diet of many larger animals, its abundance making it a significant food source even as it is a significant hunter. The fearsome centipede is, from another angle, simply one more creature in the web, eating and eaten, predator and prey at once, bound into the living community by the same flows of energy and death that bind every animal to every other. The venom that makes the centipede dangerous may also make it valuable. Within that complex toxic cocktail, dozens of compounds, each shaped to act on some precise target in a prey animal's body, lies a pharmacy that scientists have only begun to explore. Researchers studying centipede venom keep finding molecules of real interest to medicine, compounds whose ability to act on the body's systems might be turned one day to healing rather than harm. This is one of the more hopeful turns in the centipede's story. The very precision that makes the venom effective, its molecules tuned to switch specific biological pathways on or off, is exactly what makes it interesting to medicine, which is always searching for ways to target the body's systems precisely. A toxin that can shut down a particular channel in a nerve cell is potentially the basis for a drug that does the same thing for a patient's benefit. Picture the centipede's venom not only as a weapon, but as a library of molecular tools, each one a possible lead for a future medicine. Scientists are reading that library, carefully isolating compounds, testing what they do, searching for the ones that might help us. It is a striking reversal, the feared venom of an ancient predator becoming a resource for human health, its dangerous chemistry mined for the compounds that might heal. The centipede's toxin evolved over hundreds of millions of years to subdue prey, may yet yield gifts to medicine, its hidden molecular complexity holding possibilities we are only starting to uncover. One discovery in centipede venom captures the whole promise of this research. Scientists studying the venom of a centipede identified a compound that acts powerfully on the body's pain pathways, a molecule capable of blocking pain by targeting one of the specific channels that nerve cells use to signal it. In studies, this compound showed pain-relieving power that drew real scientific excitement, raising the possibility of new painkillers built on the chemistry of the very venom that causes such pain in the first place. The irony is profound. The centipede's venom hurts precisely because it speaks to the nervous system's pain channels, prying them open, flooding the body with the signals of agony. And yet within that same venom lies a compound that can do the opposite, shut a pain channel down, silence the signal, relieve suffering rather than cause it. The poison that makes a centipede bite so painful holds in another of its molecules a possible key to switching pain off. Picture the reversal. The feared toxin of an ancient predator yielding a compound that might one day ease human pain. The venom's intimate knowledge of our nervous system turned from weapon to medicine. Scientists still study these molecules carefully, working to understand them and to learn whether they can be developed into treatments that help people. The path from a venom compound to an approved medicine is long and uncertain. But the discovery stands as a powerful example of why the centipede's venom is worth studying. That hidden in the chemistry of this old hunter may be gifts for human health. The same venom that causes pain pointing remarkably toward its relief. The story between humans and centipedes is long and tangled, woven from fear, from folklore, and from medicine. We have feared the centipede across cultures and centuries, written it into myth and warning, recoiled from its venomous form. And yet in some traditions, the same animal has been used as a remedy, dried and prepared as a traditional medicine, valued for properties healers believed it held. The centipede has been both monster and cure in the human imagination. This complicated relationship reflects the centipede's real double nature, dangerous and useful, frightening and valuable, a creature that hurts and a creature that in folk belief and now in modern research might heal. Different cultures have emphasized different sides of it, some dwelling on the fear, others on the medicinal use, but the animal has rarely been simply ignored. It is too striking, too dangerous, too present for that. Picture the range of human responses to this one creature across the world and through time, dread and disgust on one hand, careful use as medicine on the other, myth and meaning layered over both. The centipede has occupied a real place in human culture, far larger than its size would suggest, precisely because it provokes such strong reactions. And now, as modern science studies its venom for medical compounds, the old folk intuition that the centipede might hold something valuable finds a strange new echo. The relationship continues to evolve, fear and fascination and the search for medicine, all braided together in our long, uneasy, enduring connection to this ancient hunter. Across the world's cultures, the centipede has earned a place in story and symbol. In some traditions it appears as a creature of menace and poison, in others as a being of power, even of protection, its very dangerousness making it a potent symbol. It features in folklore, in art, in belief, an animal that has impressed itself on the human imagination wherever people and centipedes have shared the land, which is nearly everywhere. The consistency and the variety are both striking. Wherever centipedes live, people have noticed them, reacted to them, woven them into the stories they tell about the world. Sometimes the meanings overlap across distant cultures, sometimes they diverge, the same animal cast as villain in one place and guardian in another. But the centipede is rarely absent from the cultural landscape, too vivid and too dangerous to ignore. Picture the many faces the centipede wears in human culture around the globe. Feared and respected, reviled and revered, a symbol of poison here and power there, threaded through the myths and meanings of peoples who never met. It speaks to the animal's power over our imagination, the way a creature so small can loom so large in the stories we tell. The centipede is not only a biological reality but a cultural one, a presence in the human mind across the world, carrying meanings we have layered onto it for as long as we have shared its company. In our myths, as in our homes, the centipede is everywhere, an ancient companion to humanity, in story as much as in soil. For all the thousands of centipede species, science has described many more, remain unknown, unnamed, undiscovered, waiting in the soils and forests and caves of the world. Scientists are certain that the true diversity of centipedes far exceeds what has been catalogued, that countless species still hide in unexplored habitats, undescribed by any researcher, unknown to any name. The centipede family is far from fully mapped. This is a humbling and exciting truth. It means that even now, in an age that imagines itself to have catalogued the natural world, whole species of centipede live and hunt and die without our ever having recorded them. Each unexplored patch of tropical soil, each unstudied cave, each remote forest floor may hold centipedes new to science, waiting to be found. Picture the undiscovered multitude species upon species of centipede, living complete lives in the hidden places of the world, entirely unknown to us, awaiting the researcher who might one day find and name them. The work of discovery is far from finished. There are centipedes out there, perhaps many, perhaps remarkable ones that no scientist has ever seen. It is a reminder of how much of the living world still escapes us, how much remains to be found, even among animals as old and as widespread as the centipede. The family tree we have sketched is incomplete, its branches still growing as new species come to light. Somewhere tonight in soil, no scientist has sampled centipedes that have no name move through the dark, waiting in a sense to be discovered. The centipede is ancient and resilient, but it is not beyond harm. Like so much of the living world, centipedes face pressures from the changes. Humanity is driving shifts in climate, the loss and fragmentation of habitats, the alteration of the damp and shaded places they depend on. An animal so tied to moisture and to particular conditions is vulnerable when those conditions change. And the transformations now underway across the planet reach even into the hidden world of the soil. We have seen how bound the centipede is to moisture, to the damp, dark places that keep it alive. When climate shifts dry those places, or when habitats are destroyed or broken apart, the centipedes that depend on them suffer. The animal that has survived hundreds of millions of years now faces a rate of environmental change unlike most it has weathered before, driven by a single species. Picture the damp forest floors and moist soils and sheltered habitats that centipedes need, altered or lost as the climate warms and the land is reshaped, and the centipede populations that thin and vanish as their world changes around them. It is a sobering turn in the story. The centipede's deep endurance does not make it invulnerable, and the pressures of the present moment fall on it as they fall on so much else. The ancient hunter that walked the first land and survived the ages is not guaranteed to pass unscathed through the changes we are making now. Even a lineage this old can be diminished, and the centipede, for all its resilience, is not exempt from the pressures reshaping the living world. Step back and consider what it means that the centipede has lasted so long. Hundreds of millions of years through mass extinctions that erased most of the life that existed, through the breaking and drifting of continents, through transformations of climate and the rise and fall of countless other creatures, and still the centipede is here, hunting in the dark, essentially unchanged. That endurance is a profound statement about resilience and about what allows a form of life to persist. The centipede's survival is no accident. It rests on the soundness of its design, the flexibility of its body plan, the breadth of habitats it can occupy, the hidden niche it claimed where competition is thin. These are the ingredients of true endurance, a way of life robust enough to weather catastrophe, adaptable enough to persist as the world transforms again and again. The centipede found such a way early and has held it ever since. Picture the sweep of time the centipede has crossed the extinctions. It has outlived the worlds it has seen come and go, and recognize in its persistence a lesson about what survival really requires. It is not the largest or the strongest or the most celebrated animals that endure the longest. It is often the resilient, the adaptable, the ones fitted to a durable way of life in a place where they can keep going through whatever comes. The centipede is a master of that quiet endurance, a survivor across a span of time almost beyond imagining. In its long persistence lies a kind of wisdom about life itself, that to last is to be resilient, and the centipede has lasted as well as almost anything alive. For all we have learned, the deep evolutionary story of the centipede remains in many of its details unsettled. Scientists still debate the precise relationships within the centipede family, and between the centipedes and the other great groups of arthropods, how the branches connect when they diverged, what the earliest forms were truly like. The picture is far from complete, and active research continually revises it. This ongoing debate is a sign not of failure, but of how genuinely hard these questions are, and how much remains to be discovered. The events that shaped the centipede unfolded hundreds of millions of years ago, and reconstructing them from fossils and from the living animals is painstaking, uncertain work. Researchers weigh the evidence, propose competing trees of relationship, and revise their conclusions as new fossils and new analyses emerge. Picture the scientists still arguing productively over the deep history of this animal, where it came from, how its lineage branched, how it relates to the insects and spiders and crustaceans that share the arthropod tree. The centipede has not yet given up all its evolutionary secrets. The broad outline is clear enough, an ancient lineage among the first on land, distinct and long-enduring. But the fine structure of the story, the precise branchings and relationships and origins remains contested, a live area of science where the last word has not been spoken. The centipede, familiar as it is, still poses real questions about its own past. Questions that researchers continue to wrestle with the deep history of this old hunter, not yet fully read. There is a striking imbalance in our knowledge of the centipede. These animals are abundant, ancient, widespread, present in enormous numbers across nearly the whole planet, and yet they remain remarkably understudied. Compared with the attention lavished on more charismatic creatures, the centipede has received relatively little, and vast areas of its biology, its diversity, its behavior remain poorly known. There is a wide gap between how much centipede there is in the world and how much of it we actually understand. This gap is part of the centipede's story, and part of its quiet appeal to the scientists who do study it. So much remains to be learned, species to describe behaviors, to document venoms, to map evolutionary puzzles to solve. The centipede is not a closed book, but an open and largely unread one, a common animal that has somehow escaped the depth of study its abundance and antiquity might warrant. Picture the imbalance, a creature found on nearly every landmass present in the soil beneath us, in vast numbers, alive for hundreds of millions of years, and still, in so many ways, a mystery. The work of understanding the centipede is far from done. In some respects it has barely begun. For all that this account has gathered, it represents only a fraction of what there is to know, and much of what there is to know no one knows yet at all. The centipede waits abundant and ancient and understudied, for the attention that might finally close the gap between how much of it exists and how little of it we have trouble to understand. To study the centipede is in a sense to look back toward the dawn of animal life on land. As one of the most ancient terrestrial lineages descended from among the first animals to walk the dry world, the centipede offers a living window onto that distant beginning. A creature whose deep antiquity and conserved form preserve something of what early land animals may have been like. In the centipede, the present touches the most ancient past. This is part of what makes the animal scientifically precious beyond its venom and its behavior. A lineage this old, this little changed, this close to the origins of terrestrial animal life, carries information about that origin that few other living things can offer. By studying the centipede, researchers glimpse something of the early chapters of life's move onto land, reading in a living animal the echoes of a time hundreds of millions of years gone. Picture the centipede as a kind of living link to the deep past, its ancient body a window through which we can peer, however dimly, toward the first animals to claim the land. It connects us to a moment almost unimaginably remote, when the ground was newly colonized and the ancestors of the centipede were among the pioneers. The animal in the dark beneath us tonight is in this sense a messenger from the dawn of terrestrial life, carrying in its old and conserved form a trace of beginnings we can otherwise barely reach. To understand the centipede is to understand a little more about where animal life on land began. Even the centipede's venom, studied as closely as anything about it, holds secrets we have not cracked. The cocktail is so complex, dozens upon dozens of compounds, many of them found nowhere else, each acting in ways we are still working to understand, that mapping it fully remains an unfinished task. Scientists still aren't sure exactly how all of these molecules work, how they interact in a live strike, what each one does, or what possibilities still lie hidden among them. The venom remains in important ways a mystery. This is fitting for an animal that has surprised us at every turn. Just as the centipede's behavior proved richer than expected, just as its evolution remains debated, its venom too resists complete explanation. Its full chemistry and actions still beyond our grasp. Each study seems to uncover more compounds, more complexity, more questions. Picture the venom as a deep and only partly read text, much of it still in a language we are learning to decipher, holding within it both the secrets of how the centipede kills and perhaps gifts for medicine we have not yet found. The work of understanding it continues, and with each advance the picture grows richer and in some ways more mysterious. We have learned that the venom is potent, complex, medically promising, and we have learned too how much about it we still cannot explain. It is one more way the centipede keeps its distance even as we study it. One more unfinished question in the long account of an animal that, for all our attention, has not yet told us everything it knows. So we come to the end, and the centipede remains where it has always been, in the dark beneath us, moving. We began in dread, recoiling from the venom and the speed and the rippling too many legs. We have travelled through the strangeness of its body, the intelligence of its hunt, the wonder of its life and abundance, into the deep weight of its antiquity and the questions it still poses. And at the close, the animal is simply there, as it has been for hundreds of millions of years, hunting the hidden world in the soil and the cracks and the lightless depths beneath our feet. Think of what it has crossed to be here. Among the first animals to walk on land, survivor of extinctions that erased almost everything unchanged in its essential form since before the dinosaurs, the centipede has endured across a span of time we can barely hold in the mind. And it endures still out there right now, in the dark, beneath the floor, beneath the garden, beneath the forest, flowing on its 100 legs through a world we never see. It does not need us. It does not fear us. It simply continues as it always has. We have learned much about it across these 100 facts. And we have learned too how much we still do not know: the unnamed species, the unread venom, the debated past. The ancient hunter keeps its secrets. And when the light goes out tonight and the house falls still somewhere in the dark below, an animal older than the trees, older than the flowers, older than almost anything alive, is moving patient, blind, and lethal through the hidden world it has owned since the dawn of life on land. It was there long before us. It is there now, and it will very likely be there, still moving in the dark long after we are gone.